here, so let's see if I could do this right. Choosing Zoom. Maybe I want this guy. Share. Are you seeing a presentation?
We see it.
Yes.
Yep.
I just need to go into slideshow mode, and I think I have it. Woohoo! All right. So I've done this talk a few times, and yeah, I'm just going to talk about what it's like, kind of the ups and downs, and then hopefully plenty of time for Q&A. And hopefully too, I'm hoping to inspire you folks that this is a great field. This is a really good field to be in. There's ups and downs, but overall, this is the place to be right now in 2022, and for the next million years. All right, so a little bit of background. I grew up in the Hudson Valley, and at that time, this is in the 80s, IBM was the king. They were the big software company at the time. And where I grew up, the people that worked at IBM were like looked up upon, right? My dad was a butcher. He at ShopRite, so he was like a blue collar guy. And like when we had a picnic, when ShopRite had a picnic, we went to a park and played softball. When IBM had a picnic, they rented out the county fairgrounds and had rides and cotton candy and ice cream and everything. So IBM, that field of computing was looked highly upon. And I did go on a field trip in the 6th grade to one of the plants, and it was just so impressive. Just the size of the plant was huge. The size of the computers, disk drives that were the size of like semi tractor trailer tires. Just they had printers that were amazing. The gentleman who did the tour, he was a guy that started out, a high school dropout, started out in the mailroom and worked his way up to be a manager. And he's wearing a 3-piece suit. And he did go to college part-time. He went to college, got his degree over time. So just the whole thing was impressive. And that just set me on the course for study computers. Some of my classmates, they don't know what they were going to do, or they changed their major a few times in college. So it made my planning very simple. Just focus on computers, study computer science, take math. It was recommended to take math, so I took a ton of math. Okay, so let's see, college. So yeah, I gave this talk to students at SU one time, and I did go to grad school. And early on in my career, I was thinking about just going the whole traditional route, work hard, become a manager. Oop, wait a minute, I don't want to do that. Come on. I hit the thing. Sorry about that. Work hard, become a manager, become a CIO. And through my career working at a few companies locally, I just became disillusioned. It seems like you could work hard and it didn't really go anywhere. You could get laid off. Somebody, higher level makes mistakes, they make bad decisions, and the company goes in a direction, you get laid off. So all that work, all that effort to impress whatever your managers there are now gone, right? It's a new ball game. So this was leading me on my path to freelancing. And the real kicker was working at the last company that I worked. I won't say who they are, but it's a privately owned manufacturing company. And they decided to implement SAP, which SAP is it's a software. It's the name of a software company, but their main software runs everything in a business. So basically, no matter what business you're in, you could say, well, I want to use SAP to run my operations, and they'll come in and there's software ready to go. It just has to be tailored and customized to whatever your industry is, automotive, pharmaceutical, manufacturing, medical, whatever it is. And versus starting from complete scratch, it's like a pre-built system. So anyway, it's actually a very difficult undertaking. It's companies have to go right back to scratch, to their requirements. What do they really want? How do they want their business to operate? So it is a massive undertaking, and it's difficult. But once it's done, it's worth it because you get a lot of benefits, dividends. You know what your business is doing. So anyway, I worked on this really hard project, working tons of hours. You know, I'm a salaried employee, so you don't really get paid for it. You know, working until 2 a.m., trying to meet deadlines, just working around the clock in some cases. And we were successful. The project worked, the software was working, the business was working. And then it came time to for celebration, bonuses, and I got a really lousy bonus. So that's why I call this my loss of innocence. I'd heard rumors of people having a deal already. So, you know, if you stay with the company and the project is successful, you stick with us for a month, you're going to get a 10% of salary bonus. And me back then, this is, you know, more than 15 years ago, being a non-confrontational person, I just assumed that the company would treat me well, and they didn't. I got a $500 bonus, and I was livid after all that work and effort, and $500. Ugh. So that really changed my philosophy on my working career. I didn't want to be a CIO anymore. I didn't want to be a manager. I wanted to be a consultant. I wanted to be an expert in my field and be compensated accordingly. So that was my loss of innocence. Okay, a little bit into the business aspect of freelancing. And I won't focus on this too much, just go through it briefly. But there's a couple of ways you could be. Basically, you're a company. You're your own company. You could be a sole proprietor, or you can be what this thing called an LLC, a limited liability corporation, which I think most people do, and that's what I did. So basically, it's the best of both worlds. You have a company, so you're not subject to direct liability. If somebody sues you, they sue the company and not you. And then there are some tax benefits to that as well. So yeah, if you want to go freelancing, your best bet is to go LLC. I mean, there's some fees, and yeah, I don't know, you have to pay a fee every 2 years in New York State, but it's definitely worth it. The other nice thing about being a freelancer or self-employed is the deductions. So when other people commute to work, they're commuting, but when I do it, it's a business expense. So my gasoline, my insurance, all these things, my computer, my phone, you know, everything is really used for business. So I can write that off, which means you don't pay income. You know, the money that you earn to pay for these things doesn't get taxed. It's considered an expense, and it comes off of your gross income line. But I say don't get too crazy, because some people, you know, you can't, you know, don't write off a boat. You know, don't say, well, I entertain clients every so often. Yeah, that'll get you in trouble. If you have to be somewhat reasonable with the write-offs that you're doing. And lastly, yeah, get a good accountant. Which, yeah, I can't emphasize that enough. When you're self-employed, the reporting, the income tax statements get more complicated, and you're just better off not having to worry about this stuff and pulling your hair out on April 15th. Get a good accountant, keep track of your books, and they'll keep you from getting into trouble. Freedom. This was a slide. I don't know. There's supposed to be a video here, but it wasn't working. Essentially, as a freelancer, now I'm not married. You know, I'm not married to a company anymore. If the CEO makes a strategic mistake and the company goes down the tubes, if I'm a freelancer, I don't care. I just go to the next client versus an employee. You know, if you've been there for 10, 20, 30 years, well, now it's like you're going down with the ship. Not me. If I don't like it, if I'm contracting with a client that I don't like, I just don't renew. You know, when it's over and I'm finished, I don't renew. I move on to the next one. Conversely, if I love it, I'll try to stay there as long as possible. You know, so that's what I mean by the freedom. Okay. The great aspects of freelancing. So there's pros and cons. So this first slide I highlight, let's see, this is typically compensation can be pretty good. So I had a project back in 2016 that I ended up in Orlando, and I was working my butt off. It was insane. I've never worked this hard in my life. Couple of 100-hour weeks. I think on 2 days I had like a swing shift where I literally worked around the clock, like 20 hours just in a row. And this was for Thanksgiving. I think I worked every day. I didn't work Thanksgiving, but I had a meeting, had a phone conference on Thanksgiving Day, and just worked like crazy. And that check, that direct deposit right there, that's the biggest check I ever received. Pretty awesome. You know, that's awesome. That was like 6 weeks of killing myself, but that's nice. I mean, I could have done that as a salaried employee and not got, just got my salary. So that was cool. This tweet, this is showing, I guess it's sort of, I mean, it was cool to be in Orlando, but I was working the whole time, so, in the morning, hey, nice, I got to see the sun, there's palm trees, but I'm going to be 14 hours, working on a project. I suppose there could be worse places. So still in keeping with good aspects, depending on the type of project that you get, for me in the SAP world, typically you'll have one client at a time and they'll want you for 40 hours. And not so much anymore. I mean, the remote has really taken over, but typically I travel to these client sites, and I happen to like travel. I like seeing different things. I'd say I worked in Indianapolis. I was in Detroit for 9 months, Long Island a couple of times, Baltimore, that was Orlando, of course. My current client's based in Chicago. So it's kind of, I don't know, I guess there's pros and cons to traveling, plane travel and all that stuff. But overall, I like it. I like the points. I like the miles. I like all those perks that come with being a consultant.
Hey, Glenn, Larry has a question for you. He wants to know, do you charge the client by the hour or by the project?
So typically what I do is time and expenses. So it is by the hour. I know in some freelancing gigs, you could have a fixed price type of arrangement, but you have to be really careful with fixed price. If you underestimate, well, that's the biggest problem. If you underestimate, you quote somebody, I'll do this for $5,000, and you think it's going to take you a month, and it takes you 4 months. That's not good. So my engagements, I've never done a fixed price. My engagements have always been time and expense. So you're paid by the hour. Basically, I become a temporary employee, right? I show up, I get a badge, I get an account on their email system, computer systems, and I'm basically a temporary employee. And they just tell me what to do. Work on this, work on that. How's this coming? Where are we? How come this isn't done yet? Oh, okay, this happened. Okay, all right. Try to make it up. All right, I will. Okay, let's see. The last point I had here was typically you are working with the best. It's a great way to learn. Cool thing about SAP is it's so huge. There's so many different aspects of it. And after doing this for 15 years, you think you know it all. And then you go to another project and you learn something else, something completely new. And I think that's true in a lot of, not just SAP and lots of different aspects of software. There's always something new to learn. And yeah, so as a consultant, you're working with the best, and that's a way to learn and grow quickly by working with other experts in the field.
We got another question for you, Glenn. Wayne
Sure.
wants to know what's your background as a developer, and what type of languages do you use now?
So let's see, when I was coming up, there was a language called Pascal. I learned how to develop using the language Pascal, which probably no one's even heard of now. I did a little Visual Basic. I worked for the military for a second. I worked at Lockheed Martin, actually my first job out of college, and that was a program called Ada, which language called Ada. I don't know if they use Ada anymore. I got stuck. You know, there's like 2,000 languages. There's like 2,000 computer languages out there. I spent about 3 or 4 years working in something called Pro 4. And I bet you no one's ever heard of that. Just a local company had this software product that was built in something called Pro 4. And I learned it and, developed in Pro 4 for a few years. Currently, in the SAP world, the main language is something called ABAP, ABAP, Advanced Business Applications Programming. It's only used for SAP. I couldn't use ABAP to build a website or to do anything else with it. It's proprietary to SAP, so it's double-edged sword. So in the SAP world, I'm loved, and everywhere else they hate me, right? What am I going to do if someone has a JavaScript project or a Python? I took a Python class 3 or 4 years ago, but I haven't touched it in years. But yeah, I'm kind of a one-trick pony. Yeah, so right now I've been doing ABAP for over 15 years.
Very nice. And Stephanie wants to know, how do you find your clients?
So initially, I found clients through websites dice.com and monster.com. And then after a couple of years of being in this, I just made connections with recruiters. This is probably not typical of regular freelance, but there's a whole industry of recruiters that's looking for contractors, and they're probably looking for Python people and JavaScript. I shouldn't say that. Yeah, usually I work with a bunch of recruiters, and they'll ping me with opportunities. So yeah, I'm on probably 200 recruiter email lists, and whenever they have requirements, they'll just they pump it to their 5,000 people, and if I'm interested and available, I'll follow up with them, and then have interviews. Have probably phone screen. Usually there's not an in-person interview for what I do. Usually it's cool with a phone screen or a Zoom. Yeah.
Nice. Another question in the chat. Doug wants to know what qualifies as expenses.
So let's see. For me, like I said, my computer, my internet, internet costs, phone costs. I can write off a part of my house. There's a deduction for a home office. Any kind of travel, any kind of plane, train, wherever I'm going, to a client site, hotels. Yeah. Meals, that's a big one. Meals, of course. Yeah, usually if I'm going to a client, usually I'm eating pretty well. That's when I order the surf and turf. I don't do it at home on my own dime, but when I'm out at the client site, that's when I really enjoy myself.
And a follow up to that, in terms of what you build a client, is any of that qualifies as an expense?
Let's see. Yeah, so if I'm on a time and expenses contract, I will pass that along to the client. But if I'm not, certainly sometimes I'll go to meetings too. I'll go to professional meetings, conferences, things like that. The clients aren't sponsoring me for that. I'm doing that on my own, but I'll write those trips off because they are related to business. And sometimes you might don't tell anybody this, but maybe I go to Florida for a 1-day conference, but I spend a week there. It's really like a vacation. I did some business, but I'll probably write that whole thing off. So shh. I mean, everybody does that actually. But yeah.
Very
So
nice.
some of the perks, yeah.
Thanks a lot,
Let's
Glenn.
see.
Oh,
Go ahead.
you got, just wanted to call out. We got about 7 minutes left.
Oh boy. Okay.
Yep.
All right. So I'll just spin through the rest of this pretty quick. Let's see. Yeah, some of the crappy aspects. You are away from home. If you're traveling, if if you're married or whatever, if family things come up, issues come up, it's hard to have relationships if you're away like a week, 4 days a week, and you're only home on the weekends. If you have a very needy partner, that could be trouble. On the taxes side, there is a double charge of Social Security tax. When you're employed full time, the employer pays part of that Social Security tax, and you pay. I think we pay. The employee pays 7.5%, and the employer pays 7.5%. When you're self-employed, you pay the whole 15. So that's not great. But you can claim it back in another way, but it Social Security tax sucks. Sometimes these are lucrative positions, so there's competition. It can get cutthroat. Sometimes clients will play consultants off and one against each other and keep the one that they like the best. So that could happen. So I mentioned that I've had some good times, made some good money. Well, there's also tough times, slow times. So this is a Medicaid card. Several years back, I did not work for a year, and that really sucked. And the year goes by so fast. I was trying to find other projects, but it was a really bad time for the SAP world. And when you don't work, when you're out of work for a certain amount of time and your income is very low, you get to qualify for Medicaid. And yeah, so I'm not really proud of this, but I'm not ashamed either. When times are good, it's great, making tons of money. When they're not, then it's not good. And whatever, if I qualify for something, I will take it. Anything that I qualify for, I'll take it. All right, let's see what else. All right. Yeah. So when you're freelancing, you're probably making good money. You have to be disciplined. You don't want to just blow it all and getting, the greatest, getting, Rolls Royces and everything else. You do have to plan for the downtime. So it's important to be disciplined and save. You got to pay your taxes, bills, everything else. This never say I don't know. I'm wavering a little bit on this. You have to be careful if a client is asking for something. You don't want to come out and just say, I don't know. You want to say something like, I'll get back to you, right? They're not paying you, 50, 60, $100 an hour to not know something. You might legitimately not know, and you never want to BS anybody. You don't want to just spout BS, but there's better ways of saying, I don't know, such as, let me look into that. Let me get back to you. I'll get back to you tomorrow, whatever. You just don't want to sound like you don't know something. I'm going to skip this. Upwork. Upwork is a freelancer's website that really is not that good. I had a weird issue with them that I'll talk about. Well, I'll talk about it later if you want. So here's my contact information. Feel free to reach out to me. I don't know, is there any other questions?
Yeah, I might have missed it. You mentioned that you didn't really like doing Upwork. Is there any other like website or app or service that you had used in replacement of that, or?
So I guess for Upwork for me is a little bit different, right? So I'm a senior person in my field. I'm an expert, and the rates are just in the toilet. I mean, they're really low. Now, when you're starting out as students, that's a different story. It's actually probably a good way to get some experience. And since you're inexperienced, your rates you're going to have real low rates anyway. That's just the way it is. So I would say, yeah, I mean, maybe try Upwork. Yeah, I think there's a site called Fiverr. I never use these things, right? Like I said, I'm connected with a bunch of recruiters, and usually I'll get the inside scoop on different gigs, or other consultants will call me, so hey, the lesson learned from that is create, form a network, right? Your classmates, stay in touch with your classmates, stay in touch with your instructors and your guest speakers. Stay in touch with these folks, because that will get you closer to the choice jobs and gigs. Yeah.
All right, thank you.
You're welcome.
Coming up in about 2 minutes left. Are there any other questions?
So do you guys have this? You have my contact info. I'm going to show you one other thing. Is there a question?
No, I was saying I was good. I didn't have any questions.
Let me see if I could share another thing here. Let's see if it'll let me share this guy. Can you guys still see? Can you see my screen?
Yes.
Do you see my Gmail?
So yeah, I don't know if it's Gmail, but it says like Excel, Word, and so on and so forth.
Ah, crap. All right. Let me see. Here we go. All right. So now this should be my Gmail. I just want to share one other thing, and I'm not trying to brag here. So I just invoiced my middleman company. So this is the kind of income I'm able to make. So for April of this year, I'm getting this. Now, of course, you got to take out federal taxes, state taxes, medical insurance, which really sucks. So I'm not trying to brag, but I'm hoping to inspire you folks. This is a great field to be in. The decision you've made to get into this field is the best decision you've made in your lives. There's lots of opportunity here. And right now we're at a time too, where these skills are in demand. There's going to be a war for talent. Employers are more flexible than ever before, looking to find opportunity in any place they can find it, finding quality people, any place they can find it. So whatever you have to do to finish this course, hours, ask people for help, don't, try, work on something, for an hour or two, and then don't be afraid to ask for help. You definitely want to complete this course and get into this field. Let's see. All right, I think that's it. Good luck, guys. Good luck, everybody.
All right, thanks a lot, Glenn. Thanks for coming out. But before you go, could you put up your LinkedIn information one more time?
Oh, sure,
Students?
absolutely. Let me see. Should be this guy. Share. And let's go to the bottom. Can you guys see that? Maybe I should expand that. Come on.
If you scan the QR code, it will take you to his LinkedIn page.
Trying to get this thing to.
I'll say, Glenn, if you put it back up and they scan the QR code, it will take them right to your LinkedIn page.
Right. Yeah, that's my QR code. It's just a little bit small. I was hoping to put it in slideshow mode, but the Zoom thing is in the way. I can't. I'm not able to get to the to make it bigger.
It's okay. I just pinged it in the chat, so they have it. But we do want to thank you for coming out, Glenn. You're welcome to stick around if you want to. If that's all we got today, I'll hand it over to Ryan to finish up, Cass.
Thank you.
You're welcome.
Thank
Keep at
you.
it. Keep at it. Keep at it, man. Make it happen. You guys, we need you. We need you folks. Make it happen. Cheers.
So, the thing that Glenn didn't say is that he has the reputation as being the person at OpenHack who's always spending the whole OpenHack on his LinkedIn. And Glenn, you can tell me I'm wrong there, but I don't think I'm wrong there.
No, yeah, I'm usually doing LinkedIn maintenance at OpenHack. Yeah, I think networking is huge. It's critical. You never know when that next opportunity is going to come from. So yeah, try to make connections and link in. You never know where that next opportunity is.
Yeah. Sweet. Well, thanks again, Glenn, for chatting with us, but I think we're going to get started here. So today's our last day of networking. The last day I'm going to be teaching for you folks. So our homework assignment at the end of this class today is going to be the New York Times project. But we have a little bit to work up to that point. Mostly just sort of definitions and a little bit of practice and working with an API. We've got a little exercise, an in-class exercise to do that. And then, yeah, I'm going to set you loose in the New York Times project. So let me share my screen here and we can get started. Okay. Screen. Oh, wrong screen. There we go. Okay. Also, I want to say thanks everybody for coming to the office hours who was able to make it. I'm pretty sure they were recorded and I'm pretty sure Max uploaded them to a place where you can access them. If that's something you would like to access and you weren't able to make it.
Time is it?
Cool. So today we're going to be talking about these things called REST APIs, and we're going to finish the day with the New York Times project. So let's quickly go over a really high level what we've talked about so far. Oh, Wayne, I'm going to mute you. Okay. So to start off with, at the very beginning of this class, we talked about HTTP. We talked about protocols. HTTP, the protocol that web browsers use to speak to web servers. We talked about things like methods, URLs, headers, status codes. Then we talked about how you can make requests with tools like Postman, Fetch, and curl. We talked about JSON and a bunch of custom headers, JSON being that way you can encode data to send it to a server and get back a response. And then finally today, we're going to be talking about REST APIs, and that's going to sort of finish up sort of the progression here if we went through. So I really think it's important we differentiate between sort of like a website and a web API. Now, both of these are responses that a server might return for a request. So you make a request to a server, the response that comes back from the server will contain some data. And in the case of a website, that data is going to be some HTML. It's going to be sort of for a user. It's going to some examples of websites might be something like careersincode.org or google.com. You go to that website and you get back a bunch of HTML that sort of shows information for a user. Cool. You'll notice though, something like careersincode.ml isn't really meant for a user. Like all the sort of requests we've made, they don't return HTML. They return sort of computer data for computers, or in yesterday's examples, they return JSON, and most of these web APIs return JSON. So an example of sort of a web API is something like careersincode.ml or the New York Times API we're going to use later today. I'm going to mute you. So careersincode.ml is an example, or the New York Times API we're going to use later today is an example, or another example might be another API we're going to use later today, GitHub's API. So these responses are not meant really for humans. Just turns out that humans who are a little more technical can kind of decode them and understand what's going on, but they're not really meant for non-technical people to really parse and understand. Today, we're going to be talking about pretty much exclusively web APIs. So we're going to forget about sort of the website category. We're going to be talking about, oh gosh, freaking earbuds falling out of my ear again. Sorry, folks. We're going to be talking about exclusively web APIs, requests to servers that return data that computers are going to parse. So what does API even stand for anyway? Application Programming Interface. So let's sort of unpack that a little bit. Application Programming Interface, a set of interfaces that can be used when programming applications. So interfaces, what I mean by that are sort of ways by which you can talk with, or well, I want to use the word interface, but it's not good to use a word in its definition. A way by which you can sort of communicate with or sort of affect another external system. And then application programming, sort of the programming you've been doing in JavaScript or any sort of programming language. So typically the way these sort of work is they sort of give you, for lack of a better term, hooks and handles you can use to access another external system and sort of affect it in some way. So far, most of our stuff with careers in code.ml has been read-only. So you get data from that, it comes back, you do stuff with the data. But web APIs can also have sort of write functionality. You can make a request, let's say like a post request with some data, and it can affect that external service. I also want to call out that APIs, they don't really have to use HTTP to communicate. So web APIs tend to, but an API could also just be like things like set timeout, or things like the fetch function, global function in a web browser. That still sort of satisfies all the same constraints. It's a sort of functionality that you're accessing within a programming language, and it's sort of causing an external system, the web browser, to sort of change or sort of affect its state in some way. So you'll hear the term API thrown around a lot. And it's important to realize that an API doesn't have to be a web API. A web API means it's an API that you access over HTTP. So that's sort of like a subcategory of API. So for example, the New York Times API, which we're going to use later today, that's a web API. And that allows us to programmatically access New York Times book data. But also, similarly, JSON.parse and JSON.stringify, those are APIs in a web browser that allows us to programmatically access JSON tools for sort of encoding and decoding JSON. So those are both valid kinds of APIs. So web APIs, sort of jumping into that subcategory of APIs. It's kind of like a happy accident these even exist. Like, remember how we sort of made a big deal earlier in the class about how the only language web browsers speak is HTTP? And you sort of, if you want to do anything with a web browser on a web page, it's got to be over HTTP. Well, what sort of happened was people were writing web tools, and they realized we really want these web tools to interface with third-party systems. And the only real way they had for web browsers to do that is over HTTP. So they decided, okay, I guess we're going to sort of come up with a way by which we can use HTTP as like a communication mechanism for interfacing with this remote system. So it's not, because of that, and we sort of, as we go forward here, you're going to see how a lot of these web APIs, the way they're kind of built is like you sort of had the constraints of HTTP, and you had to sort of fit in a way by which you can communicate with those constraints in place. So this is kind of a common thing in software, this whole like, oh, we just sort of have this existing system when we kind of got to make what we want work given the constraints of the existing system. You'll sort of see how that plays out as we go forward, I think. So over time, people came up with different approaches for laying out these HTTP-based APIs. Like originally, some people were just like, okay, well, we're just going to use get and post. Like, so if you want to like get data, you'll use get. If you want to like sort of write data, you use post, and you're good. And then sort of that, there was some evolution there. You can structure your paths in sort of different ways. Like maybe you make the path for something like a noun singular, maybe make it plural, maybe you sort of do something else. How do you send your data? JSON. There was a long time where XML was sort of the thing. There's a whole, if Glenn were still here, he could probably comment a little bit on it, but there was a whole thing with like this thing called SOAP and these things called WSDLs, and like there's all these sort of crazy techniques by which you can do this stuff. We're just going to go over sort of one of the more common modern techniques these days, and that is called REST. So REST stands for representational state transfer, which is kind of a, like, I don't know if that's the best acronym. I mean, I guess it's correct, maybe technically, but it's probably overly confusing. Whenever you see REST, what you should think of it as is a number of rules that define Web API best practices. So we're going to go through a bunch of these rules today. And I think like the best practices thing is really important, because what we're going to realize is REST sort of assumes this idealistic world where you're doing sort of idealistic things. And in practice, the world's never that perfect. And you have to sort of do things that REST doesn't allow for. And what it ends up meaning is you just make things up sort of on the fly. And I don't think there exists, maybe like in some academic setting, but I don't know if there exists a REST API that 100% follows all the rules. It's just sort of like the way these things end up going. But anyway, I'm sort of getting off on a tangent here. We'll get back to that in a second. So REST APIs define how state, data that's on the server, is being represented and transferred between a client and a server. I gave you a link here. You're welcome to look at it on your own. This sort of stuff can get very academic very fast, like how you're supposed to do things and all that. If you want sort of that academic take, you're welcome to click on this link. We're not going to go through it in class because I frankly don't think that the academic take is all that important, but to each their own. Yeah, so the best practices, you're probably going to break some of these at some point, but they're like a good default option. Okay, the most important concept in REST, in my opinion, is what's called a resource. So remember how we talked about paths and HTTP are sort of like nouns? You can, if you were to subdivide a path into sort of sections that are separated by slashes, sort of every sort of section of that path, every sort of level, in REST, you tend to consider a resource. And a resource is a thing that you perform actions on within the API. So maybe like a car dealership might have a car resource, a customer resource, and a salesperson resource. You can see how these are sort of thinking about a car dealership. These are all the sort of nouns in the picture. And these nouns probably have relationships to each other. Like maybe a customer might be able to buy a car, and a salesperson might sell a customer a car. So you can sort of think like you've sort of got like a bunch of dots and then a bunch of sort of lines between all the dots. And you can sort of represent all these in like interesting ways. And you can maybe maybe you want to ask the API things like, which cars did this salesperson sell today? Or which cars did this person buy? Or which customers did this salesperson sell to? So REST APIs sort of facilitate representing a lot of those questions in ways that allow you to sort of query that data via sort of an HTTP interface. So the first sort of philosophy, we've got these like REST philosophies to go through. Like this is sort of, it gets a little academic, but the first philosophy is what's called Crud, or they technically call it, I guess, like uniform interface. Crud stands for create, read, update, and delete. And you're probably going to hear this acronym a lot. So these are, if you think of like a list of items, like let's say a to-do list, okay? And you want to sort of be able to perform any sort of modifying operation of that to-do list. Create, read, update, and delete. Those are the 4 core actions you need to be able to sort of adjust that to-do list in any way you want. So let's sort of go through it. Read is kind of obvious. You want to be able to look at your to-do list. Like if you can't do that, like kind of what's the point of the list? So read, let's take that out of the picture. Create, update, and delete. So create, that allows you to sort of make new items in the list. Update allows you to modify items. And delete allows you to remove items. So if you think about it, if let's say you can sort of represent any sort of thing you'd want to do here with those CRUD operations. So let's say I've got my list and I want to add 5 items and then like update the first item to have some new text in it. And then maybe delete like the second item. I can sort of go through and perform a request for each of those operations. So I can make a request like request 1, 2, 3 to make those sort of items at the end. request 4 to sort of update the first one, and then request 5 to sort of delete the second one, for example. But I'm sort of getting ahead of myself a little bit here. These core operations always have to be completed on a resource. So when I say create, I don't mean create in a vacuum. I mean create, like insert resource name here, read insert resource name here, update resource, delete resource. Not every resource implements every one of these CRUD actions. For example, let's say in sort of our car dealership example, maybe there's a noun or a resource called like a sale, like sort of that happens every single time. Like you create a new sale whenever a new salesperson sells a car. You probably don't want to allow people to delete sales. Like sales probably can be created, read, and maybe updated. But like, if you delete a sale, like maybe there's some crazy situation where that could happen. But like generally when you make a sale, like the sale's final or something. So that's an example where maybe you wouldn't want to implement all your operations. But like, here's some examples of sort of these applied. So you can maybe create a new car. You could update a car. So create a new car, you receive a new car in the lot. Update a car, maybe you want to change the car's price, or delete a salesperson. Maybe a salesperson in like the business terms became redundant, or it's no longer needed, or it's not doing their job well enough. So you decide they have to go. You can delete a salesperson. So you can start to see here, like sort of how this ends up getting patterned. So how do these actually get implemented? Well, this is what you'll see this pattern a lot for CRUD and REST APIs. So to create, well, to start with, the resource name in URLs is always plural. That's really important. It's not /car, it's /cars, plural. In like, it should be, ideally. Of course, the rules get broken sometimes. Sometimes there's good reason to break those rules, but ideally, they're plural. So to create, it's post/resource plural. To read, it's get/resource plural. And that'll give you back a list of all of the resources, or get/resource plural / the identifier for the resource. And it'll give you back just one resource. So you can sort of read all of them or read one. And sort of sometimes one of those is more important than the other. And sort of you'll get a chance to see that a little bit later. For update, you use the request put. So we've so far only talked really about gets and posts, but this is where some other request methods are going to come in. So update uses put. And what you do is you sort of put data that's usually encoded in JSON in a body to /cars/ the identifier for the car. And that allows you to sort of update that car with the data that's in the body of the request. And then delete is you make a delete request. So there's a request called delete, and you make a method called delete, and you make that the /cars/ the identifier. And then what that'll do is that'll sort of get rid of that item on the list. The other thing I forgot to mention is the post, that has a body too. So the ones with bodies here are the create and the update. And the read and delete don't have bodies. Read doesn't have a body because it's a get, and the delete doesn't have a body because it doesn't really need one. You're just telling it to delete and that's it. There's no sort of like data to delete with or something. So usually the way it tends to work is you make a post to /resource plural /cars with the data in the body in JSON that sort of represents the initial state of that thing. So maybe, well, I'm going to talk about that in a second, but you'll sort of maybe want to make a car. And then maybe then later on, you might want to like update that car if you want to change its price. So you do a put the /cars/ the car ID. And then maybe you want to like read the price. Maybe like so you're sort of working with a customer, you want to show them the price. So you sort of do that, get the /cars ID or something like that. And then maybe finally, once that car gets sold, maybe the way you sort of decide to structure your data, you decide, okay, well, I'm going to delete that. So you make a delete the /cars/ ID. So you sort of have all your core operations there. And I'm going to show you some examples here in a second, but that's like really high level, sort of the CRUD bits in REST. Oh yeah, more methods than get and post. Okay, so here's this sort of spelled out. So if I make a post slash cars with something like this in my body, so company, Pontiac, model name, vibe, for example, sort of, I'm creating a new car. Content type application or accept, content type application JSON, accept application JSON. So I'm sending it JSON, I'm getting back JSON. What typically the way the convention is when you make a post to a resource to create something, you get back a 201 created. So not a 200, a 201. Some APIs you get back in 200. None of this stuff is like set in stone, but this is just like sort of academically what you're supposed to do. And what you'll get back, you'll notice that our data we sent now has a field called ID. And in different systems will be named different things, but ID is a good default that a lot of systems will use. And ID sort of stands for identifier. And this sort of is a value we can then sort of use in place in other places to sort of refer to this item. So if you think of this sort of cars list being empty, we make a post to slash cars with this data, and this request completes. Upon the completion of this request, we'll now have a single item in our list of cars with a company of Pontiac, a model name of Vibe, and an ID of this long thing. And those sort of have like those three values stored. Okay. So then let's say we want to read. So we want to get our sort of our whole list. So we make a get the slash cars. And then we get back 200. Okay, so everything went good. We get back a JSON array, an object with our data in there. So if we made this request before we made the post, so we made sort of the get and then we made the post, this data would be empty. You just see an empty array. But because we made this afterwards, now we can see that our data sort of contains the data from that post. So this is sort of how we can like maybe confirm that our thing worked. Or let's say you wanted to show a user a list of all the cars. This is sort of how you might do that. Okay, let's say we decide we want to update the car. Maybe we want to change the company that the car was made by. So this is where that ID comes into play. So you can see here where we're making a put the slash cars slash ID. So this ID is this value here from the original post request. So we can make a put to that and then include in the body something like company Ford, not Pontiac. Now it's Ford, and the model name still Vibe. And then now we're able to sort of get back that 200, and now you can see the data is updated. And after making this request, if we then made a get the slash cars, we would get back an array with an object in it. And then in that object, we'd sort of have the ID, all three of those fields, but the company would be Ford and not Pontiac. So you can see here how like each request is sort of performing one of these CRUD operations, but they're performing it to sort of the same backing data. And when you make a request then later on, it sort of allows you to sort of view the state of what happened with the previous request. So that's a common thing you'll see with REST APIs. And later on in the class, you'll be building some of these, and you'll sort of get to see a bit how the sausage is made here, but we're not there yet. Okay, cool. Finally, delete. So similarly, delete, we've got this sort of ID in there. So when I do a delete, the convention tends to be you get back a 204 no content. So 204 is a status code that means successful, but I'm not going to return you any response data. It's just like it worked, and that's it. So you can see here there's no response body, and that's how it tends to be with 204s. So that's sort of all the CRUD operations laid out. Before I move it forward, I'm just going to open it up if anyone has any questions. Okay, we are going to keep moving forward then. So why are these rules important? Because you could sort of build your own thing. There's nothing against that. The thing that this does is it's a standard set of rules that anyone can follow. And it means that when a developer comes along who's never seen your application before, they can look at the API you're interacting with, and they can understand a lot about it just by looking at how sort of those interactions work. So like if they saw something like this, they'd know immediately, okay, if this is a REST API, we've got a resource called cars. It has IDs. There are fields called company and model name in each car. And they can now pretty easily build on top of it. They can now sort of, because they know how the sort of REST paradigms work, they can build their own application that sort of implements, like, as long as it's sort of speaking this language, they can just talk with the server, like completely abstract from sort of the application we're in, sort of the web page, and they can sort of build their own thing all sort of separately. So it's kind of sort of nice to have that predictability. It's not a requirement, but it's kind of nice. And I'll say, maybe this is a bit of a digression, but the way this stuff was sort of done way back in the day, and if you look at like really old code or code from folks who maybe are not as classically trained, what you end up with are a lot of requests where your API ends up being focused more around like performing actions. So you can see here with REST, we're sort of, our API is sort of structured around data. Like cars is a thing where there's like a list of cars. And sort of another approach might be, let's say you make a request to an endpoint like, I don't know, like update car price. Like that's the name of the endpoint, like /update-car-price or something like that. And you make it like a post to it, and you include data in the body. And if you did it that way, what you would do is sort of like, it would almost be like you're sort of calling a function on the server remotely. Like you're saying like, call this update car price function and give it a bunch of data in the body as like a parameter. And that works. But what it means is the API view is exposed is now very sort of tightly coupled to the application you're building. So every single, like what ends up happening is every single API call ends up mapping really closely to like a button on the front end, or like sort of an action you perform on the front end. And there are pros and cons of this, but it means that your API can't be reused as nicely in other interfaces. So if now all of a sudden, instead of like, maybe you have an app where like part of the primary thing in the app is updating car prices, and now all of a sudden you want to like update car model names, you now have to implement like a whole new endpoint, which is like /update car model name. Wouldn't it be nice if there was just sort of a generic way you could sort of update properties in the data? So you can sort of see how like you can sort of evolve your way from like this remote procedure call or sort of like just like function-based like thing to sort of REST and where things have kind of generally landed. We'll say there's been some sort of future iteration after REST, and some folks have brought it up in DMs with me. So I'll say a word like GraphQL is a thing you might run across, and some folks have. And that's sort of like a next sort of iteration on top of REST. But generally, I would say REST is sort of the place right now that's sort of the most common way by which front-end applications interface with back-end web APIs. So it's probably the one that's most important to sort of learn and wrap your head around. Okay, I did too much talking. Let's move on. So there's always special cases, and this is like where I'm getting at here. Where like not everything fits into the whole CRUD model. So like here's maybe an example. What if you have like a thing where you like sell cars, and you sort of want like an endpoint that you make a request to? It's like sell the car and sort of like update values on the car. Like that sort of probably sounds a lot more similar to that remote procedure call sort of style thing where you're sort of like making like posts to like update car price. The thing is like that stuff comes up still, and like you can't always get around it with REST. So what you end up doing in this case usually is sort of making something up, sort of sticking some sort of action on there somehow, like cars, car ID, sell. And you say like, that seems like that's a post to me. And you just sort of like make the call. And now all of a sudden you've got this endpoint here, and it sort of does some additional action on the resource. And this is just sort of how it goes. So this isn't like strict REST, but it's like how REST often gets implemented is you end up doing stuff like this. Okay. There also are what are called nested resources. So imagine that a car has a relationship with a bunch of users that owned it over time. So maybe you might want to expose something like a nested resource of owners underneath a car. because like maybe you want to do something like get/owners/car ID/owners could show you a list of all the owners of the car over time. You can sort of see here how like it's still like a list of users or a list of owners that are being returned, but it's sort of like it's allows you to sort of present a bit of a narrative there to the API, some context around that. I really want owners that are related to this car. So it's, and there are other sort of ways of expressing this, but this is a common pattern you will run into about like, oh, maybe I want to sort of have things like an additional sort of level of filtering on that sort of resource based on sort of the thing before it. Yeah, we'll get to this with some of the GitHub API stuff later. They've got some nested resources that are kind of fun. So we're going to get into a bit more of the like less sort of academic-y REST stuff, but sort of the stuff that's just helpful to know when interacting with REST APIs, sort of the way things often end up working. So a pretty common operation is you've got, you're making a request to like get/resources. So like get/cars. And you want to sort of take that super long list you're getting back and you want to filter it somehow. Like maybe you want to filter by all cars that are made by Ford and just only want to return that data. The way that tends to be done is with query parameters. So what you do is you sort of set a query parameter equal to something like, usually by convention, it's like the name of the field. There's something like maybe model name, and then you set it equal to the thing you want to filter by. So an example of that might be, well, okay, I'm using users now. I guess I switched examples here. But let's say I want to, well, okay, I even broke my example here. Cool. Let's make this like name. So let's say a user has a name within it. You might do something like get user's name, Ryan. And sort of that'll filter by all users that have the name of Ryan. There's other sort of query parameters that end up getting used for certain things. I think I'm going to get into that in a second here. So yeah, I'm going to save these two here for in a couple slides. But like filtering a list is a pretty common operation you'll run into. The good thing is usually this stuff's documented. So hopefully you'll get some documentation with whatever API you're interfacing with. It's usually not just like, hey, here's an API, go figure it out. It's usually like, hey, here's an API and here's a document sort of outlining all the requests you can make to it. If you're lucky, some curls that you can sort of like work with, and then sort of information about maybe like some gotchas or like authorization headers or things like that you need to include. So anyway, just a quick review before we go any further. I want to just remind folks what query parameters are because we haven't really used them all that much. We talked about them earlier on in the class, but we're going to use them a bunch sort of today. And we're going to talk about them a bunch today. So query parameters, they're in the URL or in the path, technically part of the URL. So it's you have sort of the whole path part and then the query parameter part's at the end, after the whole path part. It's sort of the like the slash bit. So the query parameters start with a question mark, and they sort of have the name of the parameter equals, and then the value of the parameter. Then you have an ampersand, and then name of the next parameter equals the value of the parameter, and on and on and on. And you can have as many parameters as you want. Note that the names of the parameters have to be unique. So you can't have two parameters called search, or, well, I guess depending on sort of what the server does with that, maybe you could, but you tend to not do that. You tend to have parameters that are sort of like named all uniquely. And it's just a single flat list. So what you end up getting when you parse this is sort of a key value sort of representation. So search is the key, Ryan is the value, limit is the key, 20 is the value, sort of thing. Okay, so let's go do a little example here of filtering. So I'm gonna open up Postman here. I'm gonna open up a new tab. So you might have guessed, but careers in code.ml has some REST resources on it. In particular, has a resource called users. So I'm going to go to careersincode.ml/users. I want to make a GET request to that. So I'm right now performing a CRUD operation, performing a read.
Are we following this with you?
You're welcome to follow along if you'd like. Not a requirement though. If you want me to give you a second to get things open, let me know. Otherwise, I'm just going to keep going. Okay, I'm going to keep going. So I'm going to make a get to careersandcode.ml/users. So I'm performing a read on the resource users, and I'm getting a list of all those users. So I'm going to send that request. Okay. You can see here, we got back some data. So you can see it's JSON. That's a good place to start. The very top, it's got sort of some keys here. So total, page, next page available, and data. And data has a big array. And this array is an array of objects. And it looks like each of these objects represents an item in that sort of REST collection. So I'm going to guess that total here is the total number of items in that REST collection. So this case was probably like 50 users. We'll talk about pages in a second, so I'm going to ignore that for now. And sort of here we've got our data. We've got a bunch of information about each person. So this is, let's see. This is Joshua McQueen. Lives at 917 Willow Oaks Lane. It's 38. Lives in Louisiana. Ooh, interesting. Cool. Okay. Oh, and that's an awesome email address. Superito.com. Okay. Sorry, I'm getting distracted. But we've now sort of made a request to our /users endpoint. Cool. Now, there's a bunch of sort of filtering parameters in this user's endpoint. And normally you'd get some documentation along with this, but I just sort of happen to know some things about this endpoint. So I'm just going to sort of like verbally tell you the documentation right now. And that is that there are some query parameters named every single one of these fields. And if you specify it and set it equal to a value, you can filter all the data being returned back to only items or only rows that item equals that value you specify. So for example here, let's say I want to filter users that all live in the city of Philadelphia. So what I might do is do question mark city equals Philadelphia, something like that. Okay. I'm gonna click send. Did I spell Philadelphia right? 1L. That's what it was. Okay, there we go. So now I made that request. I got back 2 results. So there are 2 people that live in the city of Philadelphia, and it is Russell Weatherspoon and Clifford Plotkin. Cool. Okay. So this is an example of filtering. So you can see here that in this case, the city is Philadelphia there, and the somewhere here, city. Yeah, city Philadelphia. There we go. So they're both equal to Philadelphia. So that's filtering. Sort of an example there. You're welcome to give that a shot on your own. If you make a request to this URL here, which I will put into Slack, I will C3. Make a get to that. You should get back some interesting data there. Okay. So moving on. Let's say you have, you're someone like Wegmans, you work at Wegmans, and you're making an endpoint to represent every single transaction they've had. Okay. So, I mean, I imagine most, if not all of you have been to Wegmans. You sort of know they churn a lot of people through that store, like every day, or every one of their stores every day. And like, when I say a lot, I mean like probably easily thousands of people. And like some of those big stores, like easily to like tens of thousands of people in like, so it's like a lot of data. If you think about each of those transactions being represented as like a JSON object, maybe it's like maybe like a kilobyte, like 1,000 bytes of data, 1 byte being a character. So like, let's just say like that's like maybe every transaction is about a kilobyte. Like you're starting to get like in the many megabytes, maybe even like hundreds of megabytes territory. And that's enough data where like sending all that back in one request, you can do it, but it's going to be slow. Like the sort of data we've been sending back in those requests, like in Postman, have been many cases less than a kilobyte. I would say we haven't sent anything back that's been like, everything's been less than a megabyte, like less than 1 million bytes, 1 million characters. So like it's been like small amounts of data. But when you're starting to talk about big amounts of data, interesting new constraints start to come up. So if you want to represent all data of all transactions at Wegmans over all time, like just like taking away any sort of time filtering there, like that's gigabytes and gigabytes of text. That's just infeasible to make to send in a single request. So how would you do this? Because most likely, like if you have like a list, if you want to show like a list of transactions in an interface, you're going to need transaction data. You can't just like not send this data. So there's a trick that's commonly often used. It's called paging. And I think the best way to think about how this works is imagine you've got a big list of data like this. If you're showing it to a user just doesn't really physically have the ability to process in their head like millions and millions of data points. Like it's just sort of too much data for a user to make sense of. So what you do is, how much data could a user make sense of? Maybe like 50 rows at a time at max, maybe like 100, something like that. So what if you did something where you sort of made a request and you said, in this first request, give me the first 50 rows. So like 50 rows of data is not too bad. Like that's feasible. And then in the next request, you said something like, okay, I'm going to make the same request, but now I'd like you to give me the next 50 rows of data. So the first request contains rows 0 to 49. The next request contains rows 50 to 99, and so on and so forth. And what you can do is if you want to, if you do want to show that whole list, you could sort of make like a bunch of requests and sort of get the data 50 rows at a time. And what's cool is, because often these sort of interfaces, you're showing lists of data, the way they work is sort of like you have a big scrollable list. What you can do is when the user gets to the bottom of the list, they can sort of click next page, and that sort of kicks off that next request for that like rows 50 to 99 sort of thing. So that's how these like endpoints that have lots and lots of data often work. So more said in a little bit more of a technical sense, you split your data up into chunks. You tell your data how big each chunk is, and that's called the page size. And the number chunk that you want to fetch, and that's called the page number. So with paging, those are sort of the two things you'll run across: page size and page number. And then to request data, you start by making a request for page 1, and then you see if the data that came back is all the data you want. If you want more, you make a request for the next page. If you don't want more, you're done, and you just sort of keep making requests for next page, next page, next page, until you have enough data to do what you want to do. So you might have guessed I implemented paging. So let's go back over into Postman here. Let's get rid of our parameter there. And you can see this is where these page parameters come in here. So you can see here, I didn't specify any sort of query parameters. I'm just getting you that whole list. Now, let's see how many results we have in here. I'm going to guess I probably did 10. Wait, actually, can I do this? No, I can't. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 10 of them. Okay. Yeah, so I've got 10 objects in that data JSON array. So the total here, it says is 50. So there's 50 objects in total in that list. I'm on page 1, and it says there is a next page I can fetch. So this is sort of a nice parameter, and a lot of systems won't provide this to you, but it's helpful to have. So I'm going to do question mark page equals 2. Okay, make a request of that. Now, before I make that request, I want you to notice this first person here is Joshua McQueen. Okay, I'm going to change this to page 2, and you're going to see this first person here is going to change. Now this first person is Russell Sturgis. Oh yeah, Russell Sturgis. We wait, no, this was that was Russell something else from Philadelphia. Oh, okay. So you can see here now, sort of our first request was the first 10 items. And now our second request is the next 10 items. So item 10 to item 19. And you can see here, we got page 2. Next page is available. So we can we got sort of the second page. So maybe we might want to get our third page, for example. Okay, cool. You can see here now we've got Janice Adams. We are fourth page, so we can keep on going, paging through all of them. Maybe go to our fifth page. Okay, and you see here, now all of a sudden, this next page available flag became false. So that's sort of a hint that, oh, there's only 5 pages worth of data. We're on page 5, our page size is 10. So, okay, so like total 50, 5 times 10, 50. So like that sort of makes sense too. But well, we can check that for sure. Let's try to fetch page 6. And there we go. Page 6 is empty. There's no data on page 6. So we've sort of gotten through all of our data, sort of like gotten through it chunk by chunk. And now we're at the end. So this is sort of roughly how pagination works. Let's see if I really got fancy and I implemented a page size parameter. Something like maybe, let's say 2. I don't know if I got this fancy. No, I didn't get this fancy. So some systems will just have a fixed page size and you don't have control over it. Other systems will give you control. But the way that tends to work is you pass in a query parameter called something like page size or page length or yeah. So there's other ways to do pagination. This sort of method of pagination has some downsides. To sort of give you a thread to pull on if you're curious. Imagine so you've got all your items ordered here. Imagine you create a new item and that sort of goes to the beginning of the list, how that's going to sort of affect your pagination offsets. And there's sort of some solutions to that, but we're not going to get into that now. This is a fine default way to do pagination in most applications that you're going to be working on, I think. So that's pagination. Any questions on that?
Yeah, I have a question.
Yeah.
With the query parameters, can you use any parameter that's part of the returned object or just parameters that the author of the API has set up to use?
Just parameters that the author of the API has set up to use. In practice, most of the time, the filtering parameters you'll use happen to match the parameters in the response body because it sort of makes it nice and easy and convenient. But there's no real rule there. It's just sort of a convention.
Okay, thank you.
Yep. Okay, if there's no other questions, I'll keep moving forward here. So, philosophy number 2, because now we're all philosophers or something, getting all academic. Statelessness. So if you noticed here, none of these requests sort of explicitly depended on a previous request. They could all sort of happen independently in any order. And no matter what you did, the result would be like a valid state to be in. So in general, to perform a sort of CRUD operation or a basic operation like that, requests should not be dependent on each other. So this is a really contrived example, but imagine it took 2 requests to update a property. Like that would be a sort of against the rest philosophy. You want to sort of make operations as much as you can be a single sort of operation and a single request. Okay. item potency. This is a fancy word. So the word is item potent. I think I'm like 90% sure that's how you say it. No one's ever corrected me. So I hope I'm not haven't just mispronounced it for years or something. And what it means is the same request, when you make it again, it should do the same thing. So here's an example of why this is important. Let's say you have a button in an interface and you click that button and it does a thing. It makes a request over your REST API. Let's say the button creates a user, okay, or creates a new item in a REST resource. So what you do is you have the user, they click a button and that makes a new REST resource. And they click the button again and their internet's like kind of slow. It's sort of like churning, and then decide like, okay, something isn't working. I'm gonna click it one more time. And then all of a sudden the internet gets fast again. And then those two requests both get processed by the server. So what the important thing here is like those two requests, they sort of, you're doing like two things. You're sort of creating, and they both sort of independently should create. Or maybe another example is like, let's say it's an update instead, and you sort of perform two updates. The way that should work is an update should be able to happen completely independently. You shouldn't have sort of like a dependency on one update depending on the other or something. You should just be able to make a request with an update, and it tends to be the last update wins. And that's just sort of how it works. So that ends up meaning that the system's a lot easier to reason about. Another sort of update or another sort of example I specified here, which might be a little bit more clear. And this is, I don't know if how like realistic this is. In certain contexts, maybe you could do it, but like imagine you had a request that incremented a value. Okay, you make a request to an endpoint and increments a value. And you have a request where you make, or you have an endpoint where you make a request to it and it sets the value to be like a new value. So if you imagine that increment endpoint, you make a request to it in that sort of like you click the button, sort of, then it churns and it waits. And then like all of a sudden it gets fast again and two requests go in. You've now incremented that value twice because you sort of received two requests. Where if you did something where like you sort of took the current value, updated it on the front end, and then you sort of made a request and sort of both those requests were like set the state to be, or like update the value to be like 5, not like increment the value, then now both those requests are doing the same thing. So the result that you have at the very end, even if you send multiple requests, is that your data still acts as if you click the button once. You can't always do this. It's like, but it's cool when you can build a system with properties like this that sort of make things like duplicate requests sort of irrelevant or less relevant. It's sort of a complicated concept. So if anyone has any questions, feel free to ask, and I'll try my best to explain it again. Okay, I will keep moving forward then. This is one of those things where like, it probably is going to make more sense after you do it a few times. It's also like, just like all of REST, it's sort of idealistic. It's like, it'd be great if you could do this, but in practice, a lot of systems, it just becomes infeasible to have a guarantee like this. So, okay. So the third philosophy in the sort of REST dogma is client server. What does this mean? Well, it means that there's sort of a role for the client to play in the system and a role for the server to play in the system. More practically, it means that REST APIs should maintain a consistent resource format in bodies. So let's think about a bit like back to our JSON sort of example where we were sort of going through the exercise of adding and removing fields and sort of how that sort of affects a system, okay? Now, imagine you have an API you're interacting with, web API you're interacting with, and then decide all of a sudden to remove a field. Now, your server is sort of, when it decodes that, it gets undefined for something, and it sort of expects there to be a value there, and all of a sudden sort of stuff starts maybe breaking in weird ways. The rule with REST APIs, which should be followed, but often is not, and I sort of shake my fist when it is not, is that you never remove fields from a resource. So you only add fields. And keep in mind, renaming a field is the same thing as like deleting the field and creating it with a new name in sort of the context of like as a consuming client. So if you want to add a new field, cool, no problem, add a new field. If you want to update the name of the field, technically in like the most strict version of this, what you should really do is you should keep the old name of the field and you should make a new field called the new thing you want that's just set equal to the same value as the original field. Because if you have that original field still around and now it's backwards compatible and it'll work with everything that expects that old body format. But like because of the way JSON works, those new fields just will be ignored by systems that don't need them because they just sort of are there. They're just sort of extra data. So if you follow these rules, and deleting fields obviously is going to be a problem because those fields aren't going to be around anymore. So your old code isn't going to work. So if you follow these rules and you sort of keep your body format consistent, don't remove fields from resources, in theory, your API should maintain or should always be backwards compatible and should always work with clients that have been written for it in the past. I say in theory because it's a lot more complicated than that. And you'll maybe start to get a taste of that when you get to write your own web servers. But it's a good goal. And it's the kind of thing that in sort of an absence of other directions, like maintaining backwards compatibility is a good thing to do whenever possible. So this, I don't really have a good example for you here. Hopefully what I said made sense. Really, the big takeaway, though, is removing fields from a resource in REST is very bad. TM, very bad. And you should try to not do it if you can. Okay. Normally, when I am able to spend 2 weeks on this stuff, I have a whole day that I spend talking about caching. Because caching in web browsers is actually a really big deal. For those that aren't familiar, you've probably run across like clearing your cache or something in a web browser. Caching is a technique that web browsers use to sort of store the results of requests that are made so that in the future you can avoid making those requests and speed things up. So, for example, let's say I go to example.com in my web browser. What's going to happen is the first time I visit that site ever, my web browser is going to make a request to example.com. It's going to get back that 200 with a bunch of HTML in the body. It's going to render that HTML, and it's going to store in sort of a like a little database in the web browser. It's going to store something like domain name, and that sort of maps to like the HTML that was returned back. And then next time I visit that URL, instead of making the request to the server, it'll just return that cached HTML. Because that's fast. Like the server, the web browser doesn't have to make a request to the web server to go get all that. And if you don't have to make that request, like it's going to be much faster for a user. And most likely it hasn't changed. Like it's probably still the same data. So that ends up being like a pretty nice little performance optimization. The problem is, of course, it isn't always the same data. Websites update, sometimes more often than others. So the important thing to realize is web browsers only cache GET requests. They don't cache posts or puts or the deletes or anything like that. So if you can build your API in a way where you can take advantage of that caching by making things that are gets, like anything you're reading, make it a get. Don't like make a post to read something. If you do that, it means that you can take advantage of a lot of the browser caching. And if you set things up right, it can make things faster. So I'm being a little vague because we didn't have time to really get into caching, but it's sort of a nice property that if you can take advantage of, it's cool. In practice, I don't think any of you folks are going to get a chance to really take advantage of it all that much in careers in code, but maybe sort of it'll come up in the future for you at some point. Okay, so how you should feel about all these principles. I've said this a few times already, but I'm going to say it again. They're good default options. REST assumes a perfect academic world where everything you're doing is CRUD on resources. That's not how things actually work. Lots of things require server-side state. Things require things like cookies. Processes just fundamentally are idempotent sometimes, and you just can't like make them that way. So it sometimes can really be a losing battle if you're like really focused on how can I make this the most perfect REST thing ever. So REST provides, someone have a question? Oh, no, okay. So REST provides a lot of good guidelines. So as an API author, it's good to follow the principles when you can. As an API user, if you know it's a REST API you're working with, it's good to sort of assume that those principles have been followed. But at the end of the day, it's probably not going to be followed 100%. And if as an author of an API, you sort of can take creative license and do what you need to do to solve the problems you need to solve. And that's just sort of how it goes. So, okay. Zach.
So CRUD isn't like how the functions actually run in any sort of browser or program. It's just all best practices.
It's the best practices for exposing data on a server to a client. So as maybe a counterexample, like a thing you could do, another way you could do it. Imagine, get Postman open here. Imagine instead of users, I had something like an endpoint like get list of users, okay? So in practice, this might return data kind of similar. Okay, no problem, like this works. But this doesn't sort of follow that sort of REST naming convention. Maybe something else I could do. Let's say I have an endpoint called like update user address. And maybe the body of the request might be something like address, new address, my new address here or something. So there's nothing saying you couldn't structure an API like this. It's more just something like REST and sort of the resources and the CRUD pattern on top of that means that the API you're building is more predictable for users. It also means as a user, if you come across a REST API and you know there are things like resources called cars or called users, you can sort of start to guess what you need to make requests to. Like if I know there's a REST API and I know there's a resource called cars, I don't need to know really anything else. But I know if I do make a request to this endpoint, like, so get to /resource name, I can be pretty sure I'm going to get back a list of all the resources. And I can also be pretty sure if I make like a put to cars 23 with like sort of some maybe like model whatever in the body, like I can be pretty sure here that I'm updating a car. So that's really where CRUD and sort of REST really come into play. They give you that predictability. So you just sort of can make intuitive guesses and you can work in systems without sort of having everyone be completely bespoke. Is that helpful?
Yeah, thank you.
Cool.
Ryan, there's a question in the chat. Danielle wants to know what's the indicator of a REST API?
Yeah, good question. So I would say assuming an API is a REST API is probably a good default assumption. But I would say that the API documentation is where this is really going to come into play. So far with what we've been doing here today in class, I've sort of been reciting documentation from my head. Like I've just been saying, oh, there's a query parameter that does this, there's a query parameter that does that or something. In practice, you're going to get a document that's going to outline, here's all the requests you can make. And it might say in that document, this is a REST API. The other thing that you might see in that document, which is probably more common, is you'll see something like a bunch of requests. Like imagine, go up a little bit here. Imagine you see a document. And in that document, you see that there's a bunch of endpoints. And there's a post cars. And there's a get cars. There's a put cars ID and a delete cars ID. You sort of see that pattern. You start to think, oh, wait, this looks familiar. This looks like a REST API. Okay, the person who sort of is built this API is probably familiar with REST and is trying to follow those principles. So let me try to I can sort of assume that like they sort of are like following that path and sort of do things based on that path. So maybe let's say they don't have an endpoint documented for doing something like maybe they've got a resource called books, and they sort of have a get for books and then a create for books. They don't have an update for books. You can say, well, okay, so get/books, post/books. Maybe I'll try to make a request to put/books/ID and see if that lets me update a book. And even if it's not documented, you might find, oh yeah, that totally works. So it's sort of that layer of predictability that gives you the ability to start to understand the system at a bit of a deeper level. Is that helpful?
Yes, thank you.
Sweet. Okay. So we are going to jump in now to a real world example. I'm going to post this link in both the Zoom chat and also in Slack. So thus far, we have, as a class, not really interacted with any APIs that I didn't write. So the only one really being careersincode.ml. And that changes now. And this is the reason why we've used careersincode.ml so far, is because it's sort of an environment I've been able to control. I've been able to make for you sort of some contrived endpoints to do things. And we've been able to sort of like do some exercise and prove things out. And it's also meant that when things go wrong, I have the ability to sort of easily troubleshoot because I'm familiar with the endpoints. So now that we're going to be using third-party external stuff, it's possible stuff's going to go wrong where I'm going to have to do some digging. And it's not just as easy as like, oh, this is what happened, or, oh, let me fix that bug in the code. It's, oh, this is how the endpoint works. Okay, let's see if we can figure out a workaround by doing something. So it's another sort of level of complexity. I think you all are ready for it. But I just want to sort of call that out, that we haven't actually interfaced with another API yet, external API other than careersincode.ml. So if you get a chance, click on this and visit this URL here. I'd like if you all could follow along with me. If you aren't able to, no problem. You're welcome to do it after class or try to recreate it or something. But I think a lot of you will have a benefit to sort of doing this along with me to sort of see how this goes. We're going to be doing everything here, I believe, in Postman. Yeah, I think Postman will work. Okay. So because we're going to be doing everything in Postman, I'm thinking it's going to be pretty straightforward, but you're welcome to, if you want a challenge, to try to replicate this in curl or in fetch or something like that. But okay, so what we're going to do is we're going to make some requests to the GitHub API. So GitHub, you're probably all familiar with it, the place where you've hopefully been publishing some code. They have a really great API for things like listing repositories or seeing contributors to repositories, or things like, I don't know, pull requests or like issues, or sort of all this stuff is exposed in a really nice API. They also have, oops, let me click on that quite yet. They also have a really, really good set of documentation. Oh, I totally forgot about break. Thank you. Yeah, let's take a break now, because this is going to be sort of a whole thing. I don't want to break it up in the middle. Yeah, let's take our break now. Maybe come back at 7:30, or I guess we're already at 7:15, maybe like 7:40. How about that? This class might go a little bit long. If this is basically, we're working on this GitHub API thing for the rest of the class. And then sort of the homework is the New York Times project. But I want to give you folks a chance to start that in class a little bit here, because there's some sort of setup that's probably gonna require a little bit of hand holding. Cool. Okay, let's take our break now. We'll be back at let's say 7:40. Cool. See you then. I will also say, while we're on the break, if anyone gets a chance and can get all their stuff set up, so like if you don't have Postman open and all that, that might be a good thing to do. Just so when we're back, everyone's ready to go. You have this document open and all that sort of stuff.
Yeah, that's what I was asking in the chat. Just Postman, and then I know that you can import and then open through GitHub. Is that what you're going to be doing? Like, sort of, kind because you have your.
I mean, no, I was just gonna say, like, we're just open Postman, open this document. We're gonna sort of work our way through this documentation here to sort of make the requests we need to make. So just the document and Postman should be all you need.
Okay, do you mind throwing the outline in the chat?
Yep, I should have already, and I also put it in Slack.
All right, thanks.
Yep. recording. Knew I was going to forget to do that. Okay. So for anyone watching the recording, I forgot to re-record. We're just starting to go through this document and we're starting to generate a token here. So we're sort of going through these steps. Okay. So I'm going to enter my credentials here. Okay, sweet. So to do this, visit this link. Make sure to give your token the repo scope. This is important for the exercises to work. And after clicking generate token, the resulting token will be printed to the screen and you should save it somewhere on your computer. You won't be able to access it again, so it's important you save it somewhere on your computer for these exercises. Otherwise, you're going to have to make a new one. So if you can, follow along with me here. Hopefully, you've got the document open and you've been reading along here. But I'm going to generate a personal access token. This is sort of a token I can generate for GitHub that will allow me to perform actions. And this is, if it's helpful, maybe, this is sort of like when that exercise where we made that post request to make the token with Postman and then used it in the request after it. This is sort of like that post request, but in like a web form. So I'm going to do careers in code demo. Okay. Expiration. I don't really care about that. I guess I could select no expiration if I really wanted to, but I got to select a repo. So I got to select all the repo scopes. So I'm going to click that. Okay. And I'm going to click generate token. Before I click that though, I just want to make sure that the fields I typed here just recorded. So I entered a note or a name. I thought that used to be called name. I guess I call it note now. Expiration doesn't matter. You can put whatever you want in there. And I have to click repo. The repo here is really important. You got to select that. Okay. So I'm going to click generate. Now, I do want to point out that the token that's about to be showed here on screen is a token that could be used by anybody to make requests on the behalf of my user on GitHub. This is a value that you don't want to just be like published all over the internet. And this video is going to get uploaded onto the internet. So in general, this is probably would be a bad thing to have leaked out. So what I'm going to do, and this is just sort of, I'm saying this all in public form, so it's recorded, so there's sort of no questions about what's going to happen here. This token, I'm going to use to do the things today. Once class is done, I'm going to delete this token, so it's no longer going to be valid. So if someone comes along and watches this video and tries to use that token or do something, it's not going to work. And that's a very purposeful thing I'm going to be doing. Anyway, you folks don't have to worry about that as much because you're not going to be, your screen is going to be recorded, isn't going to be online somewhere. But in general, like, it would be a bad idea to take the token you're going to generate and like post it on social media or like put it somewhere public. Like, this is a secret value. You should treat it as such. So I'm going to click generate token. Okay, this is my personal access token. Okay, I am going to open a new window here. That gonna work? Yep, okay, it's gonna work. Sweet. I'm just gonna paste that in here so I've got access to it. Now, what's important is that this is the only time you're gonna see this value. So if you refresh your web browser, it's gonna go away. So you need to copy this and save this somewhere locally, likely in a text file or somewhere where you have access to it. Because this is, you're not going to be able to see this after you've generated it. Okay, let's go back over to here. So now when we make requests, we need to include this token within the authorization header like we talked about in class. Authorization bearer token. Okay, so that's sort of how we tell GitHub we are who we say we are. We are sort of this, I had to log in to make this token, so this token's linked with my user account. And every time I make a request, if I include it, things will happen as if my user did those things. Okay, let's go over back to the exercises here. So exercise 1. How many public repositories does the Hack Upstate organization on GitHub have? Okay, well, so to start with here, if you folks aren't familiar, there is an organization on GitHub called Hack Upstate. And that's where a lot of your repositories have been. Careers in Code, Classroom Code Base, Careers in Code website, a lot of different stuff in here that's sort of interesting. A lot of people who are instructors happen to be members of the organization. But there are a bunch of repositories in this organization. And this question, what I'm asking is, how many public repositories does the organization have? So we could go through and we could count by hand, but what's the fun in that? Let's make a request via an API. So, okay. This is really where sort of the rubber meets the road here. We got to figure out how to make this request. So let me jump over to this API documentation here. So this is this link, I clicked on it before. So these things are always, this documentation is always super overwhelming. But in any API that is of a significant size, there's going to be, you're not going to be able to read the whole thing in any feasible amount of time. So like, it's sort of, this might be a bit of a dated skill, but it's sort of like browsing a thesaurus or a dictionary. Like you sort of have to like make some educated guesses, or you're looking in sort of an index and you have to sort of to make some guesses and sort of look around here. So public repositories in the Hack Upstate organization. So maybe a place to start would be like repository. So if you see over here, there's a bunch of like what looks sort of like nouns, REST API. Okay, so we know this is a REST API. That's very good. These seem like they could be nouns, and these all are nouns. So I'll scroll down here. Maybe there's like repositories. There's organizations. Okay, that might be something we can look at. Repositories. Okay. So in this sort of question here, we have repository and we have organization. And those both are nouns. I'm going to start by going in sort of the repository route. I'm thinking like list of repositories, like repository is sort of like a REST resource, and then filtered by like organization. Like that could sort of give me that data. So let's start there. So repositories. Okay. Okay, cool. We've got curls for these. That's really nice. This is like some top class API documentation here. Like they give you like examples. This is good. This is actually better than I last looked at it, which is awesome. Query parameters. Okay, so we've got some sort of filters here you can make. Okay, before we get into here, list organization repositories. Actually, this seems like exactly what we want. Like organizations, repositories. So like there's an organization resource, or I guess they call it orgs. There's org here, which I'm guessing is like the organization ID or something. And then a nested resource within it called repos. It's probably like repositories. Okay. So headers, I can select, accept whatever I want. So I guess they have this sort of fancy accept header you can specify. Whatever, we'll get back to that if it's really needed. This one's required, organization. So path parameters, org, the organization name. The name's not case sensitive. Okay, that's good to know. So I'm guessing this org here is like this org thing here. And query parameters. So I've got all these sort of filtering things here. Okay. I do notice type, specify the type of repositories, can be all public, private, bunch of other things. This did say public. So we might need to like use type here to make that public and do like question mark type equals public. Okay, so that's maybe a thing we'll have to do. Sort, so you can change like the order in which the things are returned. You sort by created, updated, pushed, full name. Okay, interesting. So this is, okay, page, this is a paginated thing. Okay, this is good to know. So per page, the number of results per page, max 100, defaults to 30. So the page size here is 30. And then page is 1. So this is how we can sort of paginate through our data. Okay. Status code of 200 means everything went okay. Okay, cool. So this seems like a good first place to start here. So let's do this. Let's try to make a request to this. So I'm going to cheat. I'm just going to take this here. I'm going to copy this. I'm going to go over to Postman, and I'm going to go import raw text. I'm just going to paste that curl in there. Okay, so we have a request. Now we've got to fill out this org bit here. Now, let's see. Well, what could that be? Well, let's sort of look maybe at this here. See if there's any like hints. So I'm seeing all these like URLs in here, just sort of interesting. Okay. Organizations URL, that's maybe interesting. Yeah, wait, okay, this looks sort of like, wait, that's users, not orgs. Well, what could this be? Well, I mean, it's probably some sort of identifier. Oh wait, response schema, that's maybe, that's not all that interesting. I don't really know what that is. Okay. So this could be a few things. Let's start with this. So if I were to look at the organization resource, it's probably like an ID for an organization. So I'm going to open up organizations in a new tab. You can see here how like I'm working through this. I'm sort of speaking out loud here, but you can see there's some investigation. This isn't like just like, oh, it's just immediately you know what we have to do. There's sort of some guessing and checking that's going to happen here. Yeah, they have this org thing again here. Organization name. That's what this org thing is. Is there like a name field in here maybe? Yeah, name, GitHub. Okay. So, okay, here's a hint. So we see API to github.com/org/GitHub here. So this GitHub thing, this must be the name. This must be what's used here. You see how that matches? So I'm going to guess, like, if I were to look up like GitHub organization on GitHub or something, see if it'll give me that. No, it's not really gonna. Okay, well, let's start with GitHub. Like this is a known organization. Let's see if we can make a request to that. Okay, so I'll do GitHub like that. Now I gotta have my authorization information. So it said in the document that I should be able to go authorization bearer, and then go back over to my text document here and copy this and do this. So let's see if that works. Okay, click send. Oh, we got something back. That is promising. So we got back a 200. That's always really good. Okay, so GitHub. This is a little bunch of JSON. Okay, Stephanie, you have your hand raised.
Where did you get the values for application and bearer? Where did those come from?
Application. Oh, these ones.
Yeah.
So in order to get this first one, what I did is I imported the curl. And this curl, this curl right here had that in there. So I just sort of got that along for free. The other way I could have gotten that is I sort of saw headers here. It said except setting this value is recommended. So I could have entered it there. I also probably could have skipped it and it probably would have been fine. But I just sort of got it for free because I imported the curl. The authorization one, the place I got that, so that didn't come up in here, but in the document here, I sort of outlined this in these instructions. So we need to generate a token for some of these requests to work. And then it says, now when making requests, include this token with the authorization header like we talked about during class. Authorization bearer token goes here. So that's why I put that in. Now, let's say I didn't have those instructions. I just sort of came into this completely cold. I bet if I went to like maybe overview and like other authentication methods, so maybe like guides, basic of authentication, there we go. You sort of would have like a bunch of stuff here about like paths you could go about authorization. I think if I had to guess, I read through this and was like, this is way more than people are going to understand. And I just simplified it for you in the instructions. But if you didn't have my sort of simplified instruction, this is what you'd have to go through. Does that make sense? Cool. See a thumbs up. Doug, you've got your hand raised.
Yeah, can you show one more time how when you enter the curl and Postman, how you get that to populate the URL in the other spot?
So I took this string right here from this link right here.
Mm-hmm.
I copied it. I went over to Postman. I made a new tab. Then I went to File, Import. And once I got to import, I went to raw text and I pasted it.
Okay.
And then once I pasted it, I hit continue. And then it sort of imported, it sort of did its thing here. Then I clicked import and then that auto populated everything. So
Thank you. I was doing it in the wrong spot. I was using the code snippet on the side.
Ah, cool.
Thank you.
Yep. Okay. So this seemed to work for the GitHub organization. And we could verify this. Like we could sort of go to so github.com/github and sort of check to see. Oh wow. They have a whole fancy README here now. They didn't used to have this. But you could sort of start to see like, oh, like let's say there's this repository here called albino. Okay, interesting. So like I could try to put this in here. I could search for it. I could see, oh, yep, that totally exists. Okay, cool. So this seems to be like giving me some data, but it's still for GitHub. It's not for Hack Upstate. So how do we address that? Well, there's going to be a little bit of guessing and checking here. I will give you a clue, or I will sort of give a note here that that name of the organization, if you were to sort of go to Hack Upstate's organization here on GitHub, you'd sort of see that there's this Hack Upstate thing in the URL. And it seems like when you sort of like you go to a GitHub repository, it goes like organization name and like repository name. And sort of that was where it was with the GitHub URL. So it might be a good guess to guess that that is the name. Another way we could do it, well, let's start there. Let's try that out. So let's do a get for that. And yeah, now we're starting to see things that look about right here for Hack Upstate. So very old website. Cool. Yeah, so we could sort of keep on going through this here and see there's a bunch of stuff. Wow, they've got a lot of old websites. Okay. Yep. Okay. So that's one thing we could do. And to get the sort of number here, we could just count how many results are in here. And then we get that number of repositories. So that's one thing we could do. But let's say we don't like the Hack Upstate thing. We don't really know what that is. So we need to figure out what that name property is for the organization. Well, so I thought we could do that. We could sort of go into organizations. We could say like list organizations maybe. Let's see. List organizations in the order they were created on GitHub. Well, that's not very helpful. Maybe get an organization. Organization name. Yeah, it's not helpful. It's got to be a way to like, oh, list organizations for a user. That might be interesting. Okay. So maybe one thing is like, maybe you could say, okay, well, I know a user that's part of the Hack Upstate organization. So if I go over here, I maybe happen to know that I'm part of the Hack Upstate organization. And my membership is public, I believe. Yeah, so maybe I could do something like, where is it here? Yeah, users username orgs. So let me take that. I'll try to maybe import that in. Something like that. Okay. Maybe I'll put my username in there, which you could get sort of by looking at GitHub. I'll add that authorization bearer, and then that secret token value. Okay, let's try that. So send. Okay, so you can see I'm part of a bunch of different organizations. Density code, that's where I work, density. Code for Syracuse. Oh, it says those are the only two, huh? Well, okay, maybe that's not going to work. Well, okay, that maybe didn't go anywhere, and that's unfortunate. I thought that there were more organization memberships that were public that I had here. Well, you can see here, though, how there's a lot of data that GitHub exposes. And you can sort of go down rabbit holes, and you can sort of be like, oh, okay, I think I want to do it this way. And then realize, wait a second, actually, no, that way isn't going to quite work. And you sort of have to like back up, sort of reevaluate, and maybe go down a different direction. So if what you're trying to do is a little bit complicated, it might require multiple requests to be made. Yeah, Strong, I think you've got your hand raised.
So, what were you looking for, like, in your, what were you looking for here that you're saying that it's not working? Like,
yeah, so what I was thinking is like, oh, well, maybe I am part of the GitHub organization. So I could maybe, or sorry, the Hack Upstate organization. So I could see like that name value for it. And that might be sort of a way we could figure out that value. But that didn't end up working. And so that didn't end up panning out. We were able to sort of guess that though by looking at the URL, and that seemed to have worked and given us the data back that we needed. Nicole.
I have a random question. I missed the token part. So was there any specific ones I was supposed to check off?
Yeah, so for the token part here, you just need to follow these instructions right here. But essentially, it's click this link, put a name in there for the token, make sure you select the scope of repo. That's really important. And then click generate, and then make sure you take that token you generated and copy it somewhere locally so you have a copy of it. Because after you generate it, you're not going to be able to see it again. So that's all it is. Does that make sense?
Yes, it does. Thank you.
Cool. Christy, you've got your hand raised.
Okay, so so I understand that we're looking at GitHub. Why would we look on GitHub? Like, what would we be looking for? For if we wanted to do something for our project, it would be something that we would be able to find here.
Let's say, for example, you wanted to show a list of all of the repositories you've made on your like personal site, for example. One way you could do that is you can make a request to GitHub, get that list of all those repositories using something like fetch. And then in the web browser, sort of loop over those and sort of render something fancy for each repository. So that's maybe a case where like the GitHub API could be useful.
Okay. And when we get ready, just so I'll know. So if we were gonna go into another situation, not necessarily GitHub, we would follow this same type of scenario and do all of this stuff. And then, so we're going to be in Postman and we're going to be pulling our requests through here.
Yep, this is probably where you're going to start. And just so you know, New York Times exercise is going to start like this. I'm going to give you some documentation. I'm going to say, I would like you to show me this data. And it's going to be up to you to sort of work through that documentation and figure out how to do it. And it's going to be rough because every single time it's always been a little rough. And that's why I wanted to be around to sort of start it out. That being said, though, it's like the GitHub documentation is like excellent. The New York Times is like sort of like middling to okay. So it's going to be like a little bit more work to sort of make your way through it. I'm around, more than willing to answer questions and try to help you through it. But it's a sort of thing where like, I think the sort of working through it is going to sort of teach you a lot about how these things are often structured.
You're showing us the easy one first, and then later on, when it gets a little bit more complicated, we will know. We'll have some more insight.
Yeah, I'm showing you the easy one more because the GitHub API is, it makes for some better contrived examples. The New York Times API has like some actually interesting data you might want to use for something. And I also wanted to use that because it's an example of an API that's like not as well put together. So it's like more emblematic of what you're probably going to run into in, for example, like a place of employment. GitHub's API is like unusually good.
Okay.
So, and again, like I realize it's going to be a challenge, but I'm around. Feel free to send me messages on Slack. Like I know my availability has not been so great the past couple days. It's going to get a lot better sort of in the upcoming sort of time here. Still going to be on Pacific time for a little bit, but at least I'm going to be available. Cool. So let's keep moving on. There were some optional next steps in this exercise. We can maybe start to work through these here. So create a repository called GitHub API test for your user account. Okay, create repository. That sounds like a CRUD thing. So let's take a look here. Let's see in our documentation here. Repositories, that's organizations, repositories. Okay. Create an organization repository. We just want to create a repository. Is there like create repository, get repository, update, delete. Maybe create organization repository is what we want. No, it's for an organization. We want to like just make a new repository. Just search like create a repository. Create a repository for the authenticated user. That sounds about right. Okay. Okay, api.github.com/user/repos. Okay. So except we need to specify that same thing. Okay, whatever. It's a post request. Okay. Body parameters. Okay, this is where things start to get interesting. So it looks like there's a bunch of parameters you can specify to sort of tell it what you want to, like information about the repository we're going to create. So the only one that's required is name. But there's a bunch of other ones you can specify too if you want. Wow, there's a lot of them. Cool, and there's a lot of sort of response codes. So like things in different situations can give you back different codes. Okay, this, we've got a lot here, but this seems like it could be doable. So let's start with this. Let's take our curl, let's copy that. By the way, not all API documentation is going to have curls to start with. So we're kind of lucky here. We have these. If you didn't have a curl, then you just sort of need to like work through this step by step and sort of like see post. Okay, that's the method. Users repos, that's the path. So you just need to like work through it step by step and input all that into Postman. But the curls make it a little bit faster. Okay. Do that. Very cool. Okay, so we got to add that authorization header because that's the documentation said. Authorization bearer, and then that. Okay. And then we got to add a body with all those different parameters. So it's a JSON body. So I'm going to do something like name GitHub API test, something like that. So that's what it said. There's a body parameter called name. And the name of the repository. I'm kind of surprised I didn't include it in the curl. Like normally it'd have like a -d in there or something, but whatever. I guess it's just being kind of weird. Cool. Well, so we've got all the parts of our request. We've got our method, we've got our URL, we've got our custom headers, we've got our body. Let's make a request and see what happens. Repository creation exists. Oh, interesting. Okay. So what happened here? Status 422 unprocessable entity. This request is well formed. It was unable to be followed due to semantic errors. Okay, what the heck does that mean? It starts with a 4, so like we entered something wrong, I guess. Okay, so there's a clue there. But we got this body, which has some interesting data in it. Message, repository creation failed. Oh, Zach, you got your hand raised.
I got 201 created for my.
Yeah, so did anybody else do that and get a 201? Because that's what I should have gotten. And that means you did everything right for what it's worth. Starts with the 2. So Stephanie, yours says requires authorization or authentication. So if it says that, you need to make sure you've got this header entered correctly here. Make sure you generated that header or the token, and you have authorization bearer your token. This request, notice here how it said create repository for the authenticated user. You need to make sure you enter that header, or else your user is not authenticated. Like GitHub has no idea who you are. So that's really important.
I think it was I think I was entering. I entered it under parameters instead of.
Yep.
Yeah.
That would do it. Cool.
Okay.
Okay. Sweet. So in my case, I got a 422, and I actually think I know what happened here. So I'll sort of break the silence. I think I made this repository last go around when I taught this class, and I never deleted it. So I think what's happening here is name already exists on the account. I think there's a repository I have in my GitHub organization called this already. So let's check that. If I go to this, yeah, it already exists. How about that? Okay, so I'm going to do this. I'm going to delete it. Delete this repository. Cool. Okay. Very nice. So we've deleted it. Let's try making this request again. Okay. Now we got our 201. Now things seem to work. So if I go over to this here, you'll see now this exists again. I just created it. So cool. We just did a write operation with a REST API. How about that? Okay. So you folks are lucky. You're not going to have to do a write operation as part of your the careers or the New York Times project. It's only going to be reading from a REST API.
I think I missed a step because I get back a 401 unauthorized.
If you get back a 401, make sure you have your token entered properly. So let me show you what that would look like on my end. So if I were to get rid of this authorization header here and make this request,
hold on,
we get back a 401.
Go again.
So if I uncheck this authorization header here or get rid of it, I'm going to get back a 401. So you need to make sure you include this authorization header with the bearer and then your token in order for this request to work.
Right.
And make sure you're under headers and not params too.
Oh.
So
what was the value for name in the body?
I used GitHub-API-test. It doesn't really matter. You can call it whatever you want.
Thank you.
Yep. Also keep in mind, this is going to make a repository for you. So if you don't want a repository called that, after we're done, you might want to delete that repository, but up to you. So hopefully that worked for folks. It seems like it worked for some people at least. Okay. So we can update this repository now. Let's try that. See what it says. So repository resource also supports updating. Update this repository is named to something else. Okay, so there was that like update repository up here, update a repository. So, okay, this is starting to look nice. Okay, so this is using a patch method. Okay, cool. That's a little different. We didn't talk about that. Patch is a method. It sort of does some different things, sort of, but like, let's just go with it. So I'm going to copy this here. I'm going to import this thing here. Okay, cool. So owner repo, that looks sort of like this here. I'm going to put my thing in there. So repos, my username, and the repository name. Okay. The body, there was sort of all this data. Okay, I put it in that thing. Interesting. Well, that might work. I'm going to take this data out of here. I'm going to put it in raw just so it's a little easier to edit here. Interesting choice by Postman to parse it like that. But I want to update the name of the repository. So I'm just going to get rid of all these fields and just have name in there. I'm going to make this like GitHub API test 2, maybe. Okay, cool. I can do that. Yeah, let's try that. Let's see what happens. 404 not found. Okay, well, that's sort of interesting. It can't find my my repository. Why is that? Let's take a look at this again here. Update a repository. Okay. Owner repo. Well, let's do this. Let's take a step back. What if I just get this? So I do like a get on this. This is where like knowing some sort of REST fundamentals comes in handy. Like if I do a get on this, I should get back the thing that's there. Yeah, that exists. Okay. So this is definitely repository definitely exists. So why am I getting back a 404? So 404 not found. That means requested resource could not be found, but might be available again in the future. Yeah. So this path does not exist. I'll be honest, I don't really know what's going on. This should work, I would think. Oops. Let's see. Anyone have any thoughts?
Ryan, could it be because your body has API test 2 instead of actual name?
I would think I could. I would think I would. That's where I'd want to put it. But let's see what happens if I just do that on its own. Still not found. Yeah, I don't know. Okay, what about this? Let's look at the document. Oh, say that again.
I think it worked for me.
Oh, okay. What did you put in your body? Name? Oh, wait, name? Yeah. Maybe let's try description instead. That might be an easier one to update. Okay, nice. So maybe there's just something I've got slightly wrong here. Let's try like description, updated description, something like that maybe.
Do you have your authorization?
Aha, you got it. That's totally what it is. Yeah, good call.
I thought you knew you didn't have that. I thought it wasn't supposed to be there.
Oh, I forgot. Yeah, so let's put that in. And then I bet it will work perfectly fine. Huh, how about that? Okay, let's make this name GitHub API test 2 like that. Okay, click send. Yeah, now we got back at 200. You see here, name GitHub API test 2. That's very good. Okay, I bet if I go over here and refresh, yeah, now it's called GitHub API test 2. Very nice. Okay, cool. Stephanie, I think, got your hand raised.
I did do the authorization, sorry. Yeah, I did do accept an authorization, but mine's still saying the 404 not found.
Okay. I would say make sure this is correct, sort of your username and then the GitHub organization or GitHub repository name.
Yeah, it matches.
Okay. Let's do this. Can you share your screen?
Yeah.
Share my screen here. Stop share. There we go.
Oops. Share screen. Okay.
So you are not allowed to modify my repository.
Uh-oh.
So you've got my username in there. You need to put your username in there.
Error. Okay.
So something you'll find with, yep, there we go.
Okay. Thank you.
Yep. Something you'll find with GitHub and other APIs is when you get back, like you have like permissions issues, sometimes it gives you back 404s and not things like 403s or 401s. And the reason why is if you think about it, if you were to access a repository and like try to do something on it you don't have permission to do, and you get back a 401, it sort of leaks that repository exists. So if you send back a 404, this is sort of the same response as if it doesn't exist at all, which sort of like protects the privacy of whether that repository exists or not, which is why they often do it that way. So it's unfortunate because it gives you a little bit less debugging information when you like know the repository exists, but it's important in certain contexts to not leak information. Okay, so it seems like in general, you folks are kind of getting this, which is really good. I'm glad to see that. Let's do one more here. I'll leave it as an exercise to you if you'd like to try to delete the repository via the API. Should be pretty straightforward. There's a delete a repository thing right here. You can probably work through it. So Zach said, is it supposed to change the name of my repository to GitHub API test 2? It should. So if the requests work, take a look at the body you got back and check the name property and see if it was updated. Also, like the other thing too is if you look at the GitHub thing, it should have updated here. You might have to refresh your page for that to happen. No? Okay. You want to share a screen? I'm curious to see what your body looks like with that request. Okay. Oh, take a look at the method you're using. The method. To the left of you, the URL. Yeah, try that. There we go. You can see down there, updated to GitHub API test 2.
Thank you.
Yep. Cool. Postman will let you make a get or a body and a get, but you tend to not want to do that. Okay. What license does this repository use? Hint, look at licenses. Okay, licenses. Is that a thing here? Licenses, yeah. Get a license for a repository. That sounds exactly like what we want. Okay, let's try this here. I'll keep that open, what the heck. Okay, file, import. Put that in there. Okay. So we've got this whole owner repo deal again. So I'm going to enter the bit here. Okay. Got to enter that header, authorization, authorization, bearer, and then my token. Okay. Let's try that. Okay, here we go. We got some data back. We got a 200. That's looking good. So this license looks to be the MIT license. Okay. Pretty easy. Cool. So that may give you a nice introduction to APIs. Hopefully you made a request to a GitHub API sort of as part of that. If you didn't, definitely would recommend you give it a shot outside of class. And if you have any questions, let me know in Slack. But now I think we're probably at a point where we're going to move over to the New York Times exercise. Oh, can you go back to the other screen? Which other screen? Postman. Okay. This one. Strong A, you got your hand raised.
Strong J. So when you're clicking accept and authorization, are those steps in the exercise? Does it tell you to, because you went through that kind of fast.
Oh, sorry. Yeah.
And also, there was something else that I wanted to ask. So you basically did the exercise where you were finding the MIT license, because was that the point of the exercise, to get that information through Postman?
Yeah. So what license does this use? And I was just scrolling through and I saw license name MIT license. And I thought that sounds like the license it uses.
Oh, because I just clicked that link and then I went to licenses and GitHub.
This link here?
No, the link in the exercise. And once you click that link,
Oh,
you click
yeah.
license.
I suppose you could do that too, but that's not
Okay.
as fun. These are a little bit contrived. Like you tend to not, yeah, I will admit that.
Okay, so is it just showing us how to retrieve information just via Postman, pretty much?
Yeah, so I mean, these requests are being made via Postman, but there's no reason you couldn't make them with fetch or curl or any other mechanism. Imagine you had a web page, you made a request with fetch to this, and you rendered the data you got back from GitHub into your web page. Now all of a sudden, you sort of are able to get data from a third-party service into your web page, and all of a sudden it's now sort of has dynamic smart data. And that's really what this module is all about. That's sort of the end goal.
Okay. Okay.
Cool. Larry, you've got your hand raised.
That's right. Were we supposed to be trying to delete the repo or get a license?
I skipped the delete a repo because I want to move on to the New York Times exercise. I want to give you a little bit of time for that. But you're welcome to give it a shot on your own. As I sort of said before, there's a, if you go to repositories here, there's a, or what was it? I think it was repositories.
Yeah, when I did it, it gave me a 403 forbidden, and then it said I must have admin rights to the repository.
Which repository are you trying to delete?
The GitHub API test 2 that I created.
Is it your username slash or my username slash?
My username.
Okay, share your screen real quick. Sounds like other folks are also having the problem.
It says, oh, yeah, stop sharing.
Sorry, I gotta stop sharing first. Did you rename your repository GitHub API test 2 or GitHub API test -2?
Test 2.
Okay, so that name is correct.
Yeah, I'm not gonna put the dash in there just to make sure, but I'm pretty sure I had test without the dash.
Okay.
Yeah, not found.
Yeah, okay. Interesting. Well, one thing you can do, if you try to go to GitHub and go to that repository and take a look at settings. Make sure you have, oh, I don't know if you want to do that. Make sure you have permissions on it. Like you should, it's a repository you created, but maybe there's something weird going on there, possibly. So if you scroll up and click on your username up there in the upper left-hand corner, and then go to repositories, and then click on that one we just created, and then go to settings and along the top bar, and then go to maybe like collaborators under access. Huh. Yeah, you should have access to that. I mean, maybe scroll down to the left bar to the bottom.
If it's not that important, I don't want to waste a lot of time because.
Okay.
All
Yeah,
right.
there's something slightly subtly wrong with this. I can't quite figure it out right now. Everything you're doing there looks right though, for what it's worth.
Thank you.
Yep. I think I was able to answer everybody's questions. I think that probably can move on to New York Times now. Okay. So we're officially done with like new material. Like this New York Times project is sort of the last thing we're talking about. And I realize we're going to go a little long here, but sorry in advance. I wasn't really planning for Glenn's talk. Okay. So let's go over to here. So I'm going to take this link. I'm going to post it in the chat. Also going to post it in Slack. So when I go to this, we're going to get some instructions for the New York Times exercise. Now, this is sort of starts off pretty similar to GitHub. We've got to make a token for New York Times. And this is like, it's interesting because the New York Times sort of has like their whole customer facing like or user facing side to things. And they've got the developer stuff and they're like completely different systems. So you're going to have to make a New York Times developer account. And that's totally different than like a New York Times account. It's kind of weird. It's also not unusual for that to necessarily be the way it works. Like often the developer stuff is completely different. So what's nice though, is they have a getting started page. It sort of outlines exactly what you have to do. So create an account. So you got to create an account and sign in and do this whole thing here. Sign into their portal, and then you need to create an app. So you need to go to the My Apps, make a new app, enter the name and description, click create. And then you sort of can have an API key that's associated with an app. And that's sort of going to be your token that you're going to use. So I'm going to try to go through this process now. We're going to see how it goes. You're welcome to sort of try to jump ahead and see how it goes on your end. Before I do that, I want to go back. Where was it? Where was it? I just opened up the New York Times exercise. Oh, it was in this tab. So I tried to sort of outline it here. This is the thing that everyone always struggles with this exercise. Their developer portal is not the best. It's not like very straightforward. The interface is kind of confusing. So that's why I'm going to try to go through it with us. We're trying to do it all together, but we'll see how it goes. So really the rest of this is just lay out your HTML page. In there, make a script tag, use fetch to make your API request. And then once you get back your body from your request, which is going to be some JSON, the goal is to sort of show that on the page somehow. So the simplest possible way is, if you have a div you make on the page, you do something like document.getElementID in our HTML is equal to your data. And this is something that Max said you were familiar with sort of doing this. So hopefully this shouldn't look too crazy. But That's the simplest way. And what that's going to do is it's just going to render a bunch of JSON text to the screen. That's totally fine. However, I think some of you folks are probably going to want to go above and beyond. And if you want to go above and beyond, what you can do is you can loop through that JSON. You can parse it, you can sort of loop through it. And once you loop through it, you can take every book and you can do something like render a row of like create a new element and maybe set the content of that element equal to like the book name and then append that into the body and sort of do that over and over and over again. And that's how you can sort of build up your page dynamically based on data you get back. So I am hoping the whole creating HTML dynamically thing isn't completely foreign. Max said he talked about it with you folks, so I'm hoping that it maybe rings a bell a little bit. More than willing to talk it through it a little bit, but hopefully, yeah, and Mel just posted Latonia's example. So her example is like, that's about as complex as like, she kind of pulled out all the stops for that one. Also, for what it's worth, many students, after like they'll do sort of the basic version, and then like after the class is done, they're looking for sort of portfolio examples, and they'll take this and they'll sort of polish it up and make it nicer. So in Latonia's case, I'm pretty sure what she turned in was a lot more basic than what you would look at if you click that link. So maybe just to sort of set expectations there, but you're welcome to sort of get as nuts as you'd like to. I don't really have that many requirements for this project. The only requirement is that somewhere on the page, after you load it up, you have some data that came back from the New York Times API. How it's formatted, exactly how it looks, what exact data it is. I mean, other than that needs to be from that request, like, doesn't really matter. The goal here is to sort of just prove that you can make a request to an API and get data back and do something with it. If you want to get fancy, you're welcome to, though. So let's try to go through this getting started thing and see what happens. I have a feeling it's not going to work because that's always how it goes. And we end up figuring it out together. So I'm going to click sign in. I already have an account. Cool. If I were to click create an account, okay, this looks pretty straightforward, like a form that folks could fill out. I'm going to just sign in with my existing account though, because I have that. Okay. So let's see what the next step is here. So I made my account. I'm all logged in. Click sign in. Yeah. Okay. Click my apps from the user dropdown. Wait, I'm not signed in. Maybe. Click sign in. Okay, there we go. Now I'm signed in. Yeah, like it just does weird stuff like that. Where like I load the page and it's like, oh, you're not signed in, but then you click it again and now you're signed in. Okay. Apps. Doesn't even say my apps. It says apps. Cool. Okay. New app, maybe. That's what it said, right? Yeah, new app. Yeah, so this, it doesn't say my app, it says apps. So like this isn't fully consistent, but I'm hoping we can work through that. Okay, so I'm gonna call my app Careers in Code 3. I'm gonna leave the description blank. Okay. So I thought I had a thing. Yeah.
How did you get to my app? I'm on the page. I'm signed in.
Yeah. So this is really confusing. When you log in, it might say sign in this upper right-hand corner. And if you click it again, then it should show a little drop down with your username here.
Okay. And then,
that's sort of sloppy. Zach says not letting you create an account. What sort of error are you getting?
It sent me an email and says to verify your identity, click this link. I clicked the link and it just says, uh-oh, something went amiss.
That happened
Cool.
to me too, but I just I just went back to the email, pressed it again, and it worked. And then something else had happened, and I ended up refreshing the page, and then it happened, and then it was working again.
Yeah, the same thing happened to me. And then when I tried to verify it again, it says already verified. So you should be able to sign
Yeah, that
in.
happened to me too.
It's
Okay.
working. Thank you.
Okay, so yeah, I mean, this is just, these developer portals are often a little fun, so cool. Anyway,
Yeah, that's created.
oh, say that again?
So, but yeah, mine was created as well, I think.
So for the new app, we just title it whatever we want to title it.
Yep, whatever you want to call it. I'm calling mine Careers in Code 3 because I called the last one Careers in Code 2 and the one before that Careers in Code 1, but I'm not very creative. Now, I did call out here, when given the option to select APIs your application will use, pick the Books API. That's the one we're going to be using. So when you create your new app, in here, this Books API, you have to click Enable on that. So that's really important. If you don't do that, the requests aren't going to work. So make sure you enable the Books API. Okay. So, and then there's a Save button down here. Try that. Okay, cool. So we've got this API key here. This is our token, I think. Show secret. Okay, the secret too. Interesting. I thought that was our token.
How many? We only enable the one thing, the bestseller list.
The books API.
Okay, that's the only one we enable.
Yep, that's, you can enable more if you want, but that's the one you're going to need. So Stephanie said, how did you get to that page? So going through this again here, I was following these sort of steps in here. So after you sign in, you go through this register apps thing. So I go to my user up here, I go to apps, and then in here, I click new app. And I can fill out this form. Okay.
The API key, where did you get that from?
You have to click save down here at the bottom right-hand corner. Once you do that, you should get this, which I think is the API key. Pretty sure.
Ouch.
Save that.
Can you go back a little bit more, because I'm
Okay, and the type of archive, article search, New York Times, this one.
You want to make sure you select the books API.
Or the books. Enable.
Save.
Yep. Okay. Once you have your token here, I think that's probably the hardest part of this like initial step here. This next part is going to be digging through some API documentation. And this is where I'm going to sort of set you free a little bit. I'll be around for questions, but this is going to be challenging. So looking at this API documentation, this is what you've got here.
So, quick question. Okay, so there's an app ID and then there's a key. So the key is for the authorization. The app ID is for when we're making the search request.
The API key is definitely for authorization. I'm not sure where the app ID is used. I don't think it is actually used anywhere. So this request here, taking a look at it, you've got sort of a URL. That's a good place to start. You've got some query parameters, maybe. This is sort of what the response looks like. So you see you've got get back at 200, it's JSON, you got sort of an example of what it will look like. Yeah, but this is sort of what you've.
How did you get there?
How did I get there? So I was in this document here, and I was sort of, I mean, if you work through the instructions, but down here on step 3 is a link to the documentation.
Oh, okay.
So you're going to want to make your HTML page, put your script tag in there, do the whole sort of step-by-step thing there. But Assuming you do that, this documentation should have what you need to make a request. Now, a couple hints I'm going to give. This API does not follow all the REST conventions. And I'm telling you that as a hint because assuming that like is a good assumption, but you're probably going to run into situations where things are not going to work exactly as you expect. And that's part of, I don't want to spoil the full surprise because I want you to figure it out. And there's going to be, I understand there's going to be like some debugging and churning, but yeah, it's that's part of the challenge of this exercise. I also want to say, and if you're looking for a place to start, there's this nice execute button over here. So we don't have a curl, but if you remember, whenever a browser makes a request, we can open up the network pane over here and we can see that request it makes. So if I were to click execute, I can actually see over here when I click execute, if I make my thing a little wider, I think. Yeah, there we go. I click this, I can see the request it makes. Oh, and if I'm not filtering stuff here, yeah, there we go. So this is the request it makes. I can see information about it. And this will get like, this is sort of a little tester thing in here. You can use to try out the request. It says, failed to resolve API key, okay. So that might be a hint. There's also like for one unauthorized, there's a big authorize button up here. That looks kind of suspicious. Maybe try to click that and do some stuff. So I don't want to spoil the full surprise here. It actually looks like they've maybe made this a little bit nicer since we were in here last, but play around. Hopefully you'll be able to make a little bit of progress. And the goal here in this is that the place you start is in Postman. Make this request in Postman to the API and get back some data. Once you've got that request working in Postman, port it over to Fetch. Make the same request in Fetch, make sure it works. Once you've got that request working in Fetch, then put it in your HTML page and sort of do what you want with the response. But starting in Postman is probably a good idea. Okay. So that's all I've got for you today. I'm going to leave you to yourselves to sort of work on this New York Times exercise. Yeah, so Mel brought up, I would suggest checking out the document under week 10, day 4, working with JSON. It's a, you're going to be having to do some JSON munging at the end of this, but yeah, making that request is a good place to start. Okay. Sweet. Well, that's all I've had for you folks. Any final questions here?
No, just be prepared for me to be booking some time with you.
No problem. Anytime.
Where's Mel? Is Mel, are you fluent in this, or can we?
Yes, please reach out to me at any time. I'm pretty fluent in this as well.
Okay. Class, when are we gonna have, we have a study group tomorrow? What are we doing?
Sounds good. I'm with that.
Yeah, please invite me. I will join that as well.
I'm not working tomorrow, so sign me up.
I gotta read this sheet first, so.
It's funny.
Stephanie, is that, what's your availability?
I work right up till 5 tomorrow.
Oh. So the weekend. Can we hire tutors? Do they have paid tutors we can hire? I need a tutor.
I'm sure you can find one online somewhere.
Killing me.
You're doing better with this stuff, Christy, than you think you are. I'll just put that
I
out there.
probably am, but like my brain is like, what? And initially, yeah, you know, I'm gonna freak out and then I'll calm down. But especially when it's something as simple as like a tick or, you know, and then nothing is working. So
Yeah, fair enough. I mean, it just takes a bunch of practice. You'll get there eventually. Part of it is a sort of boot camp environment. Everything's sort of happening so fast where there's really not time for things to sink in before you learn the next thing. And that's really unfortunate. Because normally you don't learn this stuff at this sort of pace. Or, I mean, I guess you could if you wanted to, but it's like you sort of slowly, like over the course of years, just pick up all this stuff through like periphery and learning. Yeah, anyway. Cool.
so when is this due?
That's a good question. Why did I make the due date on this?
Yeah, 10 windows, reading a Sicily. They're not on the month.
Wayne.
My bad. Sorry.
What
did I do? What did I do again?
Talking on the phone. We're trying to get our stuff together.
Oh, I'm sorry.
So it looks like I actually made it due June 5th, and that's impossible. I'm gonna make it due June
I'm about
12th.
to say, what, retro?
Yeah.
June 5th, 2023, that works for me. That
Yeah,
works.
so you guys got a week.
Here.
And like, I'm not really all that strict about the due date. Just get it done at some point. Like this extra, I think
you need to be more definitive, because if you don't give us some parameters, or maybe like a check-in, can we schedule a check-in with you in like a week? And then, you know, so we can see where we are.
You're welcome to if you'd like. Yeah. I will, here's what I'll say. If you need a deadline, Sunday, this upcoming Sunday, so like a week from yesterday, that's your deadline. If you're someone where deadlines don't,
That's not gonna work.
It's not gonna work?
No, that's about a check-in time, so we can, we'll have a lot of questions for you. And then maybe the next Sunday, because Max is probably gonna slam us with something else tomorrow. Whew, my pressure. Ugh.
Okay, I'll make it 2 weeks. That's fair enough. The thing is though, like, so I'll make it the 19th.
I think once we, you know, it's like the end of the night. We've already done a lot, and we worked hours this morning too on something else. So this it's just, you know, my brain can only do so much one day.
Makes sense. Yeah. Okay. Well,
and I didn't get my tea from Starbucks, so my brain really is not working, because that's how it functions. So yeah.
Fair enough. Okay, folks. Well, I need to do some packing here, and it's good teaching you this week, though, or this sort of extended week here. Hopefully, I should be back in Syracuse by the time sort of you get back to the end part of your class. So maybe we'll get a chance to meet in person at an open hack, or there's usually a time at the end where there's sort of like a crunch time, get all your capstones ready to go, and they usually try to get all the instructors in person for that. So hopefully I'll see you folks in person at some point, but if not,
how is your availability on the weekend? Because usually we might need another office hour.
I'm willing to do it. Yeah. So tomorrow my availability is not good. For the rest of the week, it's not half bad. This weekend is not too bad. Then from that point on, it opens up a lot.
Okay. Yeah, a lot of people have different schedules, but I know if we can get at least 3 or 4 of us together and then record it, maybe that would so that they can see it.
Yeah,
that's what we did today. That was helpful.
Cool. Well, I will I'll reach out maybe near the end of this week and sort of see what everyone's thinking. I'll say that this is also stuff Max is very familiar with. So if you ask questions to Max, he should be able to help you. But I've taught it a few times and he hasn't, so I might have some insights that he doesn't, but
Okay.
yeah.
Well, thank you. It's
All
been
right, thanks, Ryan. Thanks, Mel.
very eye-opening working with you the last 4 days.
I'm glad it's been eye-opening. I'm gonna take that as a good compliment.
Yeah, it opened my brain a lot.
Cool. Well, thanks again, folks. See you soon.
Night, everybody.
Thank you. Good night.
Bye.